Hello everyone, my name is Wen. This is the first part of practicing Data Science 100 docs, Structured Data Processing, SQL, or SQL. This is an IPython file originally created by the Data Science Society and translated from Japanese to English by DeepL. The reason I update this file is to spread this practice, which is useful and helpful for everyone who wants to practice SQL from beginners to advanced engineers. Since this data is created for Japanese, you may face language problems when practicing, but you don't have to worry because it will not affect so much. And you have to install Docker on your PC to practice. Wait a second. Well, first of all, I got the original file from this GitHub from this repository. This is the question. You can practice Python on the SQL. And this is the answer. Okay, this is the question in Japanese. And this is the answer. Okay. But you know how to install Docker first on your PC to practice. And run this code or downloading from the file from where is it? Maybe here. Download chip, or you click here. But you should run this code on your kernel if you use MacBook. But I don't use Windows, but I don't know how to Windows, so. Or you can use SQL Alchemy instead of installing Docker. Maybe I will update the way to introduce Docker, but anyway, I recommend you Google or utilize ChatGPT to install Docker and run the code, to practice this code, okay? And you can get this file from my repository, a GitHub account. I put the link in the description, so please feel free to download this file. This is the question, so this is the answer, this isn't the question. I translate it. You can practice Python out on the SQL. This is the question. And this is the answer. I saw it. This was Python, really. But anyway, you can download the practice and the question in English, okay? And you can stop this video and download that file and practice, because I will practice Data Science 100 docs while seeing the answer. I will update this article today. It's part 1, so this is the question and this is the answer code. This is the commentary for this answer code, so you can learn this answer code and read and understand more deeply by reading this commentary, okay? And I manage my blog. It's called Chani blog. You can learn topic, TOEFL, essays, psychology, data science, etc. I made some essays. I published some books. Making the secret to master language like a native speaker, and top 100 plus strategy by a multilingualist. Since I specialize in psychology and English, I made the topic for education or psychology. For example, this about language acquirement or English education problems Korean government has. By psychology, English vocabulary, TOEFL topic. This is my profile. Okay. And if you want to read these articles in Japanese, you click here. And if you want to read articles in Korean, you click here. Okay. Okay, I'm gonna practice. So I already won this code. So the first question. Well, I wanna zoom, but I can't, so I don't need this. How was it? Well, okay, question first. Display the first 10 items of all items from the receipt details data and visually check what data is held. Okay. Select first form. Receipt. Don't need to be right. Limit. Okay. This code is written in SQL, a programming language used for managing and manipulating relational databases. This code is querying a table. Okay, I can zoom it. This code is querying a table named receipt and selecting all columns and rows from the table using the asterisk. This wide code character. The limit 10 clause at the end of the query limits the result set to the first 10 rows of the table. And in simpler terms, this code is retrieving the first 10 rows of the data from the receipt table in a database. The exact meaning and structure of the data in the receipt table depends on the database scheme and the information stored in it. Okay. Next question. Okay, this is perfect. Display 10 items from the receipt details data, specifying the columns in the order of the sales date, customer ID, product code. Oh, this is more perfect, right? Okay, I copy and paste this. And sales YMD. But this is my value to practice, not practice, for using the SQL. Okay. Sales YMD, customer ID, product CD, lastly amount. Come on. Okay. Customer ID. Where's the product CD? Oh. Okay. The specific column, sales YMD, customer ID. Customer ID, product CD, and the amount is selected using the select statement. These columns represent various pieces of information related to purchase transaction, such as the date of the sale, the ID of the customer who made the purchase, the code of the product that was purchased. and the amount of the purchase. And I explain this way. So in summary, this code is retrieving specific pieces of information about the first 10 transactions recorded in the receipt table in the database, using the column sales YMD, customer ID, product CD, and amount. The exact meaning and the structure of the data in the receipt tables depends on the database scheme and the information stored in it. I already said it, right? So, okay. Next question. From the receipt details data, specify the columns in order of sales date, customer ID, product CD, and sales amount, and display 10 items. However, extract while renaming the items from sales YMD to sales date. Okay. MD as sales date. That's it? Wait. Okay. I just change the name. Just add in the as and the as and the sales date. Then you have to change the name from sales YMD to from sales YMD to sales date. Okay. Well, in summary, this code is retrieving specific columns of information about the first 10 characters recorded in the receipt details table in the database, and using the modified column named sales date, customer ID, product CD, and amount. Okay. The next question. From the receipt details data, specify columns in the order of sales date, customer ID, product code, and the sales amount, and the extract data satisfying the following conditions. Okay, again, copy and paste. So near this receipt. Where was it? Customer ID. Sorry guys. Customer ID equal this. What the? Sorry guys. Okay. Just added this code, right? The where clause is used to filter the data based on a specific condition. In this case, this data is being filtered based on the condition that the customer ID column is equal to this. This means that the query will only retrieve data for transactions that were made by the customer with ID this. Okay. So in the summary, this code is retrieving specific columns of information from the receipt table in a database, but only for transactions made by a specific customer with the ID this. Okay, next question. Extract data from receipt details data, specifying columns in the order of sales date, customer ID, product code, and sales amount, and satisfying all the following conditions. Okay, again, copy and paste. And amount. Come on. Okay, maybe. Just added this code. So, well, The where clause is used to filter the data based on specific condition. In this case, the data is being filtered based on two conditions. Customer ID equal this code and amount greater or more than 1000. Okay? This means that the query will only retrieve data for transactions that were made by the customer ID with this and have an amount greater than or equal to 1000. So in summary, this code is retrieving specific columns of information from the receipt table in the database, but only for transactions made by a specific customer with the ID this and with an amount greater than or equal to 1000. Okay? Next question. Extract data from receipt details data, specifying the columns in the order of sales date. Customer ID, product code, sales quantity, and sales amount, and satisfying all the following conditions. Okay, again, copy and paste. And customer ID equal. Or can I or quantity greater or equal 5? Maybe okay, right? I just add this code, okay? And where are the customer ID first? The customer ID column must be equal to this, and the transaction must mean at least means this, okay? Or at least one of the following two conditions. First, the amount column must be greater than or equal to 1000. And second, the quantity column must be greater than or equal to 5. So this means that the query will only retrieve data for transactions that were made by the customer with ID this, and either have an amount greater than or equal to 1000, or a quantity greater than or equal to 5. So in summary, this code is retrieving a specific columns of information from the receipt table in the database, but only for transactions made by a specific customer with ID this, and with either an amount greater than or equal to 1000, or a quantity greater than or equal to 5. Okay? Next question. Run the receipt details data, specify the columns in the order of sales date, customer ID, product code, and sales amount, and extract data that satisfy all the following conditions. Okay. Again, well, as always, copy and paste. And I don't need this. Between 2000. Come on. Well, just add it. Wait, just add it here. The customer ID column must be equal to this, and the amount column must be between 1000 and 2000 inclusive. This means that the query will only retrieve data for transactions that were made by the customer with ID this, and have an amount between 1000 and 2000 inclusive. So, the between operator in the where cross is used to filter results based on the range of values. In this case, it's used to retrieve transactions where the amount column falls between 1000 and 2000 inclusive. So in summary, this code is retrieving a specific columns of information from the receipt table in the database, but only for transaction made by a specific customer with the ID this and with an amount between 1000 and 2000. Okay. Next question. From the receipt details data, specify the columns in order of sales date, customer ID, product code, and sales amount, and extract data satisfying all the following conditions. Okay. And product CD. Okay. Well, the difference is just added here, added this. Well. This query is filtering that the data by only selecting records where the customer ID is equal to this ID and the product CD is not equal to this. Okay, this means that the query will return all records for customer ID. Customer ID this, and except for records where the product CD is this. Okay, this means not. So this code is being executed within a Jupyter notebook using the SQL magic command persons and SQL. Okay, I didn't explain that this command allows SQL code to be executed directly within the notebook. Okay, now I'll explain it. Next question. In the following process, rewrite error to end without changing the output result. Wildcard and from prefecture CD. Was it prefecture CD not equal 13? Area. Come on, maybe okay. This code is using the select statement to select all columns from the store table. And this query also is filtering the data by only selecting records where the prefecture city is not equal 13 and for area is less than or equal to 900. This means that the query will return all records from the store table where the prefecture city is not equal to 13 and the floor area is less than or equal to 900. Okay. Next question. From the shop data, extract all items whose shop code starts with S13 and display 10 items. Okay. store. Don't need this. Store CD like S14 the percentage. Okay, maybe okay. This query is filtering the data by only selecting records where the store CD column starts with the letter S14 using the like operator with the wildcard character %. The query is also using the limit clause to limit the number of return records to 10. And this means that the query will return up to 10 calls from the store table where the store CD starts with S14. Okay. Next question. Well, from the customer data, extract all items whose customer ID ends with 1 and display 10 items. Okay. 10 items, customer. Customer ID like %. Come on. Maybe okay. Well, just change it. Just change it like. Previously it was S13%, but in this case it's from %1. So this whole code means that the query will return up to 10 records from the customer table where the customer ID ends with the number 1. Okay. Next question. From shop data, display all items with Yokohama City in the address. Okay. Don't need this. Sorry. Address. That's it? Well, just change like here. Previously it was %1, but in this case, person and Yokohama City and the %. Okay. So this whole code means that the query will only return all records from the store table where the address column contains the string Yokohama City. Okay, this. Next question. From the customer data, extract all data whose status code begins with the letter A to F and display 10 items. Okay. Select customer. The status CD administrator. Hot. A to F. Come on. Okay. Okay, I'm gonna explain this. The The query is filtering the data by only selecting records where the status CD column matches the regular expression pattern. Hat, square brackets, A to F, okay? Using the this operator. The regular expression pattern this matches only value in the status CD column that starts with the letters A through F. The hat character in the pattern indicates the start of the string, and this specifies the character range. Okay, so this whole code means that the query will only return up to 10 records from the customer table, where the store CD column starts with the letter A through F. Okay. Next question. From the customer data, extract all data items whose status code ends with the numbers 1 to 9 and display 10 items. Okay, status seed. Present 1 to 9. Just change here. That's it. So this query is filtering the data by only selecting records where the status CD column matches the regular expression pattern this. Okay, the regular expression pattern this matches any values in the status CD column that ends with a digit from 1 through 9. The dollar character in the pattern indicates the end of the string, and this specifies the character range. Okay, so this whole code means that the query will return up to 10 records from the customer table where the status CD column ends with a digit from 1 through 9. Okay. Next question. From the customer data, extract all data items whose status code begins with the letter A to F and ends with numbers 1 to 9 and display 10 items. Okay. Well. Not wildcard. A to F. That's it, maybe? Well, this query is filtering the data by only selecting records where the status CD column matches the regular expression pattern this. So the regular expression pattern this matches any value in the status CD column that starts with the letters A through F, a worldwide number of characters, and ends with a digit from 1 through 9. The character this hat in this pattern indicates the start of the string, and the dollar character indicates the end of the string. So how this code means that the query will return up to 10 records from the customer table where the status CD column starts with the letters A through F and ends with a digit from 1 through 9. Okay. Next question. From the shop data, display all the items of data where the telephone number is 3 digits, and 4 digits. Okay. Don't need this. The number. Total 9. Total 9. 3. for digitally. What the? Yeah, 3. Okay. This regular expression matches any value in the tail number column that follows the format of a body for number with the format this. Well, I'll explain this. So, and this, and I skip explanation. The 3. This and this are quantifiers that specify the exact number of digits in each section of the phone number. Okay. So the whole code means that the query will only return all records from the store table where the tail number column matches the format of a variable number. Okay. Next question. Sort customer data by birthday in order of age and display all 10 items from the top. Okay. Customers. And order by. Don't need this. Bye bye. Birthday. Limit 10. That's it. This code order by. Well, the query is sorting the data in ascending order based on the birthday column using the order by course. So this whole code means that the query will return the first 10 records from the customer table when data is stored in ascending order based on the birthday column. Okay. Next question. Sort customer data by birthday in descending order, displaying all 10 items from the top. Descending order. That's it. Yeah, that's it. Starting the desk. Okay, next question. Rank the receipt details data in descending order of sales amount per item and display 10 items from the top. The items shall display the customer ID, sales amount, and the rank assigned. If the sales amount is equal, the same rank shall be assigned. Okay. Customer. Amount. Rank. Over. Order. Order by. As one king. What's it? Why am I here? Come on. Well, I'm gonna explain from the beginning. This query is selecting the customer ID and amount columns from the receipt table. And this query also using a window function called rank, which is being used to calculate the ranking of each record based on the amount column. The rank function calculates the rank of each record by assigning the same rank to equal values in and leaving gaps between the ranks for non-equal values. The window function is defined using the over clause, which specifies the order in which to apply the ranking and any partitioning or filtering criteria. Okay. So, well, this whole code means that the query will return the first 10 records from the receipt table, with each record including the customer ID, amount, and ranking columns. The ranking column will contain the ranking of each record based on the amount column, with the highest amount having a ranking of 1. Okay. Okay, this is the last question for today. For receipt details data, assign ranks in descending order of sales amount per item, and display the first 10 items. Items shall display the customer ID, sales amount, and the rank assigned, even if the sales amount is equal. A different rank shall be assigned. Okay, different ranking. Disk. Row number. That's it? Maybe okay. Well, it's good. The row number function. Wait a second. The ranking column is derived column created using a window function called row number function. Okay, the row number function generates a unique sequential number for each row in the result set based on the order by clause provided. In this case, the function is being used to assign a rank to each row based on the value in the amount column. Okay. The order by clause is ordering the rows in descending order based on the amount column. So the highest amount will be ranked 1. The second highest amount will be ranked 2, and so on. This is also the same explanation. I wanted this. Sorry, I skipped that explanation. So the result of this query will be the top 10 rows from the receipt table with columns for customer ID, amount, and ranking. The ranking column will contain a sequential number assigned to each row based on the order of the amount column, with the highest amount having a ranking of 1. Okay. Sorry, I can't zoom on. Well, question: country number of cases against the receipt details data. Okay. Well, receipt. Don't need this. Count. When? That's it. Or you can use wide clause asterisk. Okay. The count function is used to count the number of rows in the receipt table. In this case, this statement is used to count all rows in the table, regardless of whether any columns are null or not. Okay, so in summary, the query selects and returns the count of all rows in the receipt table, including those with no values in any columns. Okay. Next question. Count number of unique cases against the customer ID of the receipt details data. Okay. Distinct customer ID. That's it. So this function, count function is used to count the number of distinct customers' IDs in the receipt table. In this case, this statement is used to count number of unique customers' IDs in the table. The distinct keyword is used to specify that only unique values of the customer ID column should be counted. So in summary, this query selects and returns the count of unique customers' IDs in the receipt table. Okay. Next question. Sum the sales amount and sales quantity for each shopcode in the receipt details data. Okay. Well. Receipt group by store city. Quantity. Oh, common. Okay. Well, for this code, the sum function is used to calculate the sum of the amount and quantity columns for each store. And the group by clause is used to group the sales data by store. This means that the query returns the sum of the amount and quantity for each unique store code in the store CD column. So the first occurrence of the code might be duplication or mistake, or it is the exact same as the second occurrence. Nonetheless, the query selects and returns the total amount quantity of products sold for each stores in the receipt table. Okay. Next question. Find the most recent sales date for each customer ID for the receipt details data and display the 10 most recent sales dates. Okay. This is perfect, right? You can see the answer and the code. No answer, maybe. The question and the code. The answer code. Receipt. Customer ID. Limit. 10. Customer ID. Sales YMD. Common. Well, this function method. The max function is used to select the maximum value of the sales YMD column for each unique customer ID in the customer ID column. Okay. And this group by method, I say it again. The group by clause is used to group the sales date by customer ID. This means that the query will only return the maximum sales date for each unique customer IDs in the customer ID column. So, in summary, the query selects and returns the maximum sales date for each customer from the receipt table and limits the result to the top 10 characters. 10 customers. Okay, next question. For receipt details data, find the oldest sales date for each customer ID and display the 10 results. That's it. Okay, just change here from max to min. Well. The min function is used to select the minimum value of the sales YMD column for each unique customer ID in the customer ID column. Okay. So in summary, the query selects and returns the minimum sales date for each customer from the receipt table and remits the results of the top customers. Okay, next question. For receipt details data, find the newest sales date and the oldest sales date for each customer ID and display 10 cases where both are different. Okay. Receipt ID, customer ID. Having not equal. Well, maybe I don't have to explain from this. I mean, this part. But I need to explain here, right? Having. The having clause is used to filter the results based on the condition. In this case, the condition is that the maximum scale state and the minimum sales state should not be equal for the given customer ID. This means that the query will only return customers who have made purchases on different dates. Okay, so in summary, the query selects and returns the customer IDs, maximum sales date, and the minimum sales date from the receipt table for customers who have purchases on the different dates and remits the result to the top 10 customers. Okay, next question. For the receipt details data, calculate the average of the sales amount for each shop code and display the top 5 in descending order. Okay. Don't need this. Proceed. And order by amount. That's it? Where is it? Customer ID. Don't need this one. Oops. Okay. customer ID of which I have to explain this way. The average AVG function is used to calculate the average sales amount for each unique store city in the store city column. Okay. So in summary, this whole query selects and returns the store codes and their average sales amount from the receipt table, sorted in descending order based on the average sales amount, and remits the result to the top stores. Okay. Next question. Calculate the median sales amount for each shop code for the receipt details data and display the top 5 in descending order. Percentile count 0.5 with an group order by amount as amount 50 per. Okay, I'm not gonna explain it here. Just wait a second. Well, this function used to calculate the median is this code. This function orders the amount column in ascending order and then calculates the value at the 50th percentile. In other words, this finds the middle value of the order list of amounts. Okay. So in summary, this query returns the top 5 stores with the highest median amount spent per receipt. Okay. Next question. For receipt details data, calculate the mode value of the product code for each shop code and display 10 cases. Okay. This can be. Well, duct by product product CD. accept. Proceed. T. そしてプロダクト CD。Here. Walk on the over partition by Desk. Okay. Maybe okay. Okay, this is the example code. First, I'm gonna make another code. Another example code. Well, almost same, but but this code is like a complicated code, so just making a simply accept. Group apply. CD by store CD emit can select Well, I'm gonna explain from this code. This is a SQL query that retrieves data from table called receipt, and the query selects two columns, store CD and the mode of the product CD column for each store. This code, this function calculates the mode of the product CD values within each group of store CD. The mode is the most frequently occurring value in a set of data. The order by clause specifies that the product CD value should be ordered in ascending order before calculating the mode. So, well, this query returns the mode of the product CD values for each store, which represents the most commonly sold product at each store. The results are ordered by store code and limited to the top 10 stores. Okay. This is a simple case of using the mode function. First, but only one mode is selected if there's more than one mode. Okay. The next code, this complicated like code, I'm gonna explain this. Well, the query uses a common table expression CTE called product CNT, this, to calculate the number of times each product has been sold at each store. This groups the data by store CD and the product CD using the group by clause and counts the number of rows in each group using the count1 functions. The results are stored in the mode CNT column. Okay. The query then uses another CTE called product mode to rank the mode CNT values for each store's product using the rank this code. This function assigns a rank to each product based on its mode CNT value within each store. The products with the highest mode count are assigned a rank of 1. And finally, the query selects the top selling product for each store using the where rank equal 1 clause to filter the results, and orders them by store and the product code using the order by clause. This returns the store code, product code, and mode count for the top selling product at each store, and remits the output the first 10 rows using the limit clause. So, in summary, this clearly finds the top selling product at each store, and based on number of times it has been sold, and returns the store CD, product code, and mode count for each of the top products. Okay. Next question. Calculate the variance of the sales amount for each shop code against the received details data and display 5 cases in descending order. Well. Receipt, store CD, where is amount? Store CD, per pop. Amount. Come on. Okay. Okay, I'm gonna explain this function. This function calculates the variance of the amount values within each group of stores CD. The variance is a measure of the split or dispersion of a set of data. The pop in VAR bird underscore pop stands for population, which means population, okay, which means that the entire dataset is used to calculate the variance. So overall, the query returns the top 5 stores with the highest population variance in the amount values, which means that these stores have the highest split of dispersion of the amount spent per receipt. Okay, next question. Calculate the standard deviation of the sales amount for each shop code for the receipt details data and display 5 cases in descending order. This is STDDEV and sorry, that's it. Okay, I'm gonna explain just here because only this period I changed. So this function calculates the standard deviation of the amount values within each group of stores CD. The standard deviation is a measure of the split or dispersion of a set of data. Yeah. So the query returns the top 5 stores with the highest population standard deviation in the amount values, which means that these stores have the highest spread or dispersion of the amount spent per receipt. Okay, next question. Find the percentile values for the sales amount in the receipt details data in 25% increments. Well. Receipt. Percentile. 0.25 within order by amount. As amount 25 per. Okay. 100, 75, 50. So this code is SQL code used to calculate percentile values for the amount column in the receipt table. This code uses this function to compute continuous percentiles, which means that percentile values will correspond to actual values in the dataset rather than interpolated values between data points. The code specifies for percentile values to be computed: the 25th percentile and the 50th percentile, 75th percentile, and the 100th percentile. These percentiles are calculated using the within group clause to order the amount column in ascending order before computing the percentiles. So the select statement at the end of the code retrieves the calculated percentile values from the query and returns them as a single row of output. This code is useful for analyzing the distribution of the amount column in the receipt table and identifying any outliers or unusual patterns in the data. Okay. Next question. Calculate the average of the sales amount for each subcode for the receipt details data and export those that are 300 maybe yen or more. Okie dokie. Receipt. Wait, what? Maybe don't need where. Store CD. Come on. Okay. Maybe you guys know this whole code if you watch this video until now. So, well, in summary, the resulting output will be a table with the columns, with two columns, through city and average amount. Each row will correspond to a store in the receipt table that meets the conditions specified in the having clause, and the average ABZ, average underscore amount column, will contain the average transaction amount for the store. This code is useful for analyzing the performance of different stores based on the average transaction amount. Okay. Next question. For the receipt details data, sum the amount of sales for each customer ID and find the average for all customers. However, exclude customer IDs with certain with set as they represent non-members. Well. Select customer amount, customer amount, average fee, some amount. Well, this is SQL code that calculates the average of total amount spent by each customer in the receipt table, excluding customers whose ID starts with the letter Z. The code starts with a common table expression, CTE, defined using the voice clause. The CTE is named customer amount _amount, and it contains the select statement that retrieves the customer ID column and the sum of the amount column for each customer in the receipt table. And the where clause filters out any customers whose ID starts with letters Z using not like operator. The results are grouped by the customer ID column, and the resulting table has two columns, customer ID and some amount, which is the total amount spent by each customer. So the next line of the code retrieves the average of some amount column from the customer amount, CTE. The select statement uses the average function to calculate the average of the sum amount column, which represents the average total amount spent by each customer whose ID doesn't start with Z. So the resulting output will be a single value representing the average of the sum amount columns from the customer amount CTE. This code is useful for analyzing the average spending patterns of customers and identifying any outliers or unusual patterns in the data. Okay, next question. For the receipt details data, sum the sales amount for each customer ID to obtain average of all customers. Extract the customers who spent more than the average on display 10 items. However, exclude customer ID starting with Z as they represent non-members. Customer amount, select customer amount. Maybe this is good. Customer amount. Form. Customer amount. Maybe okay. Well, this SQL code retrieves the customer ID and some amount column for the top 10 customers who have spent more than the average total amount spent by customers in the receipt table, excluding customers whose IDs start with the letter Z. The code starts with a CTE defined using the with clause. I already explained this, so I skipped this. So, well, next line, this line, retrieves the customer ID and some amount columns from the customer amount CTE, but only for customers whose sum amount is greater than or equal to the average sum amount calculated over all customers in the CTE. This is achieved using a subquery that calculates the average sum amount using the average function, and then filters the customer amount CTE using the where clause. The result of this query are then limited to the top 10 rows using the limit clause. So the resulting output will be the table with two columns, customer ID and sum amount. Each row will correspond to a customer who has spent more than the average total amount spent by customers in the receipt table, excluding customers whose ID starts with the letter Z. The table will be sorted in descending order based on the sum amount column, and only the top 10 rows will be included in the output. This code is useful for identifying high-spending customers and analyzing their spending patterns. Okay. Next question. Combine receipt details data and shop data internally and display all items of receipt details data and the store name of shop data for 10 items. Join store as store CD. The code. Okay. Well, I'm gonna explain here. Join and on. The from clause specifies that the data is being retrieved from the receipt table, and the join clause specifies that the store table is being joined to the receipt table using the store CD column as the join condition. This means that rows from the receipt table and the store CD will be combined into a single table based on the matching values in the store CD column. So the resulting output will be a table that contains all columns from the receipt table, plus an additional column through the name from the store table. The table will be limited to the first 10 rows using the limit clause. This code is useful for analyzing data from two related tables and combine the data into a single table for analysis. Okay. Next question. Join product data and category data internally and display all items of the product data and 10 categories of category names. of the category data. Okay. Category. P. Category small name. That's oh man. Category small. Category site names, product C, P, category C, P dot category small. Maybe here. Oh, okay. Okay, I'm gonna explain here. The code selects data from two tables, product and category. The join keyword is used to combine the rows from both tables where the category small cd column values match. This creates a new table that contains columns from the both tables. So, in summary, this code will return the first 10 rows of the combine of product and category tables, where the category small cd values match, and will include all columns from the product table and the category small names column from the category table. Okay. Next question. Calculate the total sales amount for each customer from the customer data and the receipt details data and display 10 items. However, for customers with no sales records, the sales amount should be displayed as 0. Customers whose gender code is female 1 should be included, and non-members whose customer ID starts with Z should be excluded. Well. Where is it? Amount. ID. Equal 1. Customer ID not like percent, maybe. data as 3 don't need this. Okay. Customer data as C and the same thing. Wait. Sorry, I'm rather confused. Customer. Oh, okay. See. Personal ID. And where is it? Limit. Oh, sorry. Okay, I forgot the writing on. Customer on ID equal a customer. Okay, I'm gonna explain from the beginning. This code is written in SQL and is a bit more complex than the previous one. This selects data from 3 tables: receipt, customer, and customer amount. And this code uses a with clause to define 2 subqueries: customer amount and customer data. The customer amount subquery aggregates the amount column from the receipt table by customer ID using the sum function and given an alias some amount, okay, to the result. This is alias. This subquery will create a new table that contains 2 columns: customer ID and some amount. And the customer data subquery selects all rows from the customer table where gender city is equal to 1 and customer ID does not start with the letter Z. This subquery creates a new table that contains a single column, customer ID. The final query joins the customer data table with the customer amount table using a left outer join operation. This will return all rows from the customer data table and matching rows from the customer amount table, if any exist. If there is no match in the customer amount table, the call function is used to replace the sum amount values with 0. Okay, so this code will return the first 10 rows of the customer data table along with the sum of their receipts, or 0 if they have no receipts, for male customers whose customer ID does not start with the letter Z. Okay, next question. From the receipt details data, create a data set containing the top 20 customers with the highest number of days sales and date sets contain the top 20 customers with the highest total sales value, respectively. And furthermore, merge these two completely externally. However, exclude non-members whose customer ID search is still. Well, okay. Maybe I need this. Change this customer data. Was it? Customer ID not equal to. And maybe I don't need this. Maybe don't need. Yes. Oops, sorry. Mount customer ID equals zone. Days. Customer ID. Distinct. Days. Customer data, customer. Customer data, customer ID. Was it days? What? Chani. Customer. So plus a. The customer ID. Okay, where is it? Wait for it first. Wait a second. Order by what? Line 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Maybe here. Order. Okay. Okay, this code is also written in SQL and is a little bit complex. This selects data from the receipt table and creates three subqueries: customer data, customer days, and customer amount. And the customer data subquery selects rows from the receipt table where the customer ID does not start with the letter Z and gives an alias to three columns: customer ID, sales YMD, and the amount. The subquery will create a new table that combines three columns: customer ID, sales YMD, and amount. And the customer data subquery aggregates the sales YMD column from the customer data subquery by customer ID using the discode function, and gives an alias days to the result. It then orders the result by days in descending order and remits the output to the top 20 rows. The subquery will create a new table that contains two columns: customer ID and days. Okay. Our next subquery, the customer amount subquery, aggregates the amount column from the customer data subquery by customer ID using the sum function and given areas by amount to the result. It then orders the result by amount in descending order and remits the output to the top 20 rows. This query will create a new table that contains the two columns: customer ID and by amount. And the final query, join the customer days table with the customer amount table using a full outer join operation. This will return all rows from both tables, matching the rows from both tables and no values where there is no match. The callback function is used to replace the no values in the customer ID with the corresponding value from the other table. The select code chooses three columns to include in the output. This code to get the customer ID and this, and this codes from the customer amount table, and this codes from the customer days. Okay. So this code will return the top 20 customers with the highest count days. For example, the number of days they visited the store, and the top 20 customers with the highest by amount. For example, the total amount they spent in the store, along with their customer ID. If a customer appears in both tables, it will only appear once in the output. Okay? Okay, last question for today. You want to make a data, combine all shops and all products, direct product shop data, and the product data, and calculate number of cases. Store. Cross join product select comment. What? Okay. This SQL code retrieves a count of the number of rows in the result set generated by performing Cartesian product between the store and product tables. The code starts with a select statement that specifies the count functions, and the value to be counted is 1, which means the count number of the rows. The from clause specifies 2 tables to be used in the query store and product. However, instead of joining the 2 tables together based on some matching criteria, the cross-join keyword is used. This means that every row from the store table will be paired with every row from the product table, resulting in a Cartesian product. So the resulting output will be a single row with a single column containing the count of the number of rows in the Cartesian product. This count will be equal to the number of rows in the store table multiplied by the number of rows in the product table. This type of query is generally used to calculate the total number of possible combination of data from 2 or more tables. Question 41st. Sum up the sales amount of the received details data by date and calculate the increase or decrease in sales amount from the data of the last sale and display it in results. Okay. What's sales amount? First making a winter. Receipt. Where? Well, I don't know where. Group by sales ymd and select sales ymd and some amounts okay. Log amount. Log amount. Okay, got it. Come on. Why 9? South YMD. Where is it? Right 9. Oh. So someone recept pi so what the sales YMD it's Y, right? D maybe the letters letters are different, so I have to find out. South YMD, this is okay. South YMD, okay. Saves. South YMD, come on. Okay. Well, this code is written in the SQL language and is using the with class to create two template tables named sales amount by date and sales amount by date with log. And that code is then selecting specific columns from the sales amount by date with log table and calculating the difference in sales amount between consecutive dates and using the log function. Well, more specifically, the code is performing the first with clause creates a template table called sales amount by date that calculates the total sales amount for each date in the receipt table. The second way is here, sales amount by date with log. This uses the log function to calculate the previous date's sales amount. Okay, this and the difference in sales amount between consecutive dates. And the final select statement selects from columns from the sales amount by date with work table, including the sales date, sales amount, and previous date, previous sales amount, and the difference in sales amount between consecutive dates. So the results are then sorted in ascending order by sales date and limited to the first 10 rows. So in a summary, the code calculates the difference in sales amount between consecutive dates in the receipt table using the log function and display the results for the first 10 rows. Okay, next question. Tabulate the sales amount of the receipt details data by date, and for each date, combine the date of the last previous and 3 previous sales dates. Then display 10 results. Well, maybe I can use this. Okay, first with amount by date. This is okay, this amount, okay. Well, maybe I have to change this. I don't need this, bye-bye. I'm just silly. Sales date. Sales amount was it? What date? From Susan Rockday, Chinese Susan Rockday. Let's see. Maybe okay. And this is well, this is code example first. Vertical holding case. Code one. Vertical holding case. And another code. This is horizontal holding case. Horizontal. Self summoned by date. This is okay. This self summoned. Self summoned by date. Cells, and I have to change this. Cell summoned. This is 1. Measured by cells YMD. Maybe okay. That's how I get. I don't need to join. Amount with what? By source YMD. Source YMD amount. Don't need this. Bye. Okay. Huh? From 122. Maybe here. Yeah. 34. Here? Huh? Huh? Hmm? Hmm. What? What is it? What amount? Sorry, this was OMD, not date. Okay. This is the horizontal holding case. And this is the vertical holding case. I'm going to explain from this case. Okay. This code is also written in the SQL language and using the with class to create the two temporary tables named sales amount by date and sales amount rag date. The code is then performing a self-join on the sales amount rag date table and the filtering based on the certain conditions. Okay. More specifically, this code is performing the with class creates a template table called sales amount by date that calculates the total sales amount for each date in the receipt table. The second with clause creates a sales amount rag date. This uses the rag function to calculate the sales date 3 days prior and the sales amount for each date in the sales amount by date table. And the last select statement selects specific columns from the sales amount rag date table and performs a self-join with itself. The join conditions here. The join condition filters the result to include only rows where the sales date of the one row is less than the sales date of another row, and where the sales date of the second row is less than or equal to the sales date of the first row 3 days prior. And the results are then sorted in ascending order by sales date and the previous sales date and limited to the first 10 rows. So in summary, this code is performing a self-join. This code is performing a self-join on a table that includes the sales date and sales amount for each date in the receipt table. The join condition filters the result to include only rows where the sales date of the one row is less than the sales date of another row, and where the sales date of the second row is less than or equal to the sales date of the first row 3 days prior. The results display the sales date, sales amount, previous sales date, and the previous sales amount for the first 10 rows. Okay, this is a little complicated, but you practice and learn this. Okay. Next horizontal holding case. Well. The first with clause creates a template table called sales amount by date that calculates the total sales amount for each date in the receipt table. The second with clause creates another template table called sales with rag, here, that uses the rag function to calculate the sales date and the sales amount for the previous 3 days for each date in the sales amount by date table. The final select statement selects the specific columns from the sales amount with rag table and filters the results to include only rows where the third previous date is not null. This means that the first 2 rows of the table will be excluded since they do not have the third previous date. So the results are then sorted in ascending order by sales date and limited to the first 10 rows. So in summary, this code is calculating the total sales amount for each date in the receipt table and then using the log function to calculate the sales date and the sales amount for the previous 3 days for each date. The result displays the sales date and sales amount for each date, and the sales date and sales amount for the previous 3 days. The results are filtered to exclude the first 2 rows since they do not have 3 previous date. The first 10 rows of the results are displayed in ascending order by sales date. Okay. Next question. Combine receipt details data and customer data to create sales summary data. Summing the sales amount by gender, city, and the age. Gender city should be 0 for male, 1 for female, and 9 for unknown. However, the item structure should consist of 4 items: age, female, sales amount, male, sales amount of unknown gender. Vertical cross tabulation of age and horizontal cross tabulation of gender. In addition, the age should be in the size of 10 years. Well. Well, first, okay, if I could just summary. With gender amount. CD. So it's good. not double equal maybe. Right? When gender equal, then amount else. Oops. Then amount was female. Not else? Maybe okay. Well, this SQL code creates a table named sales summary that summarizes the total sales amount by age group, era, and gender. And the first common table expression, CTE, I mean this with clause named gender era amount, is created using a join between the customer and the receipt tables. Okay. The CTE calculates the total sales amount by grouping the records based on the age group and gender. Well, and next, the sales amount table is created by aggregating the data from the gender era amount CTE. The table has 4 columns: era, and the male, and the female, and the unknown. The sum case when gender something something CTE equals statement within the select clause is used to pivot the gender specific sales amounts into separate columns. So finally, the select statement is used to retrieve all the rows from the newly created sales summary tables. Okay. Next question. The sales summary data created in question 43 has sales by gender calculated horizontally. From this data, convert the gender into 3 items: gender, age, gender code, and sales amount, by having the gender calculate vertically. The gender code should be 00 for male, 01 for female, and 99 for unknown. Okay. One. So summary. Oh. Select. Beyond all select. Yes. Select. One. Summary. female. As amount. And you select 99. Let's change your CD. Unknown amount from source. Okay, where am I spin? Oh, maybe here. Not here. Right? Oh, yeah. Well, okay. Well, I'm gonna explain. Well, the purpose of this code is to transform the data in the sales summary table to a format that can be more easily analyzed. The select statement is used to retrieve data from the sales summary data as a table, and the union of operator is used to combine the results of multiple select statements into a single result set. The first select statement is similar to the first one, but it selects the Ella and the female columns. Sorry, that was here. First statement column. And unknown columns here. And sets the gender column to 99. The result set of this select statement also contain the first select statement here. Sorry, I was confused. The first select statement retrieves data from the sales summary table and selects the Ella and the male columns. It also includes a new column called gender CD, which has a value of 00. This column is added using the string literal 00 as gender CD. The as keyword is used to rename the column to gender CD. The result set of this select statement contains 3 columns: error, gender CD, and amount. The second select statement is similar to the first one, but it selects the Ella and the female columns and set the gender CD column to 01. The result of set this select statement also contains 3 columns: error, gender CD, and amount. Next statement. The third select statement is also similar to the first two, but it selects the Ella and unknown columns and set the gender CD column to 99. The result set of this select statement also contains 3 columns: error, gender CD, and amount. And finally, the union of operator is used to combine the result sets of the 3 select statements into a single result set. The resulting table will have one row for each combination of Ella and gender CD, and the amount column will contain the value of each male, female, or unknown, depending on the value of gender CD. Okay? Next question. The date of birth in the customer data is held in date type. Convert this to a string in YMD format and display 10 cases together with the customer ID. Okay. Oh, this is so easy. Well, I'm gonna explain just here because maybe you guys know right from from function to limit and the select. So just here, the toChar function is used to convert the both date column to a string with the specified format. In this case, the format is y for y and 2m and 2d, which represents the year, month, and the day of the birth date. The resulting string will have a string of 8 characters, with the year represented by 4 characters, the month by 2 characters, and the day by 2 characters. So overall, this code is useful when you want to retrieve the customer ID and the birthday columns from the customer table and format the birthday column in a specific way. This formatted data can be useful for analysis for reporting purposes. Okay, next question. The application date of the customer data holds data in a string type in YMD format. Convert this to a date type and display 10 cases together with the customer ID. Well, I make this, copy and paste. Application date. Application date. Well. Yeah. Wait. Okay, I'm gonna explain here. The toDate function is used to convert the application date column from a string to a date format. In this case, the format is YMD, which represents the year, month, and the day of application date. The resulting date value will be in the format Y for Y and for 2M and 2D. So overall, this code is useful when you want to retrieve the customer ID and application date columns from the customer table and convert application date column to a date format. This formatted date can be used for analysis or reporting purposes, especially when date calculations or comparisons are involved. Okay. Next question. The sales date of the receipt details data holds the data in numeric type for Y to Y YMD format. Convert this to a date type and display 10 items together with the receipt number and the receipt sub number. Okay. Copy and paste again. Receipt. Receipt number. Receipt sub number to date. Virtual character. Oh, maybe okay. Cast. System ideas back character date. Well, I'm gonna explain here. This first item is the cast function is used to convert the sales YMD column from an integer to a string. The resulting string will contain the year, month, and the day of the sales date in the format. This format, okay. The to underscore date function is used to convert the sales YMD column from the is this to underscore date function is used to convert the sales YMD string to a data format. In this case, the format is this, which represents year, months, maybe you know the days of the sales date. So, well, overall, this code is useful when you want to retrieve the receipt number, receipt subnumber, and sales YMD columns from the receipt table and convert a sales YMD column to the data format. This formatted data can be useful for analysis or reporting purposes, especially when data calculations or comparisons are involved. Okay, next question. The sales epoch seconds of the receipt details data holds data in unique seconds of unit type. Convert it to a date type and display 10 cases together with receipt number and the receipt subnumber. Okay. Number. Don't need this. Timestamp. Okay. I want to explain this. The cast function is used to convert the timestamp to a date format. In this case, the resulting date value will be in the format. What? I forgot this. Yeah. Well, in the format of YYYY and DD and MM. Okay. To timestamp function is used to convert the sales epoch column from the integer to timestamp format, and the resulting timestamp will represent number of seconds since January 1st, 1970 was it? Yeah, 1970. Okay, and 0 was it? Hour minute seconds or all 0 UTC. So overall, this code is useful when you want to retrieve the receipt number, receipt subnumber, and sales epoch columns from the receipt table, and convert the sales epoch column to the date format. This formatted data can be useful for analysis or reporting purposes, especially when data calculations or comparisons are included. Involved. Next question. Convert the sales epoch seconds of the receipt details data to date type. Extract only the year. This means year in Japanese, and display 10 items with receipt number and receipt subnumber. Receipt 10 subnumber. Extract. Year from timestamp sales epoch. Okay. Okay. I'm gonna explain here. Extract. The to underscore timestamp function is used to convert the source epoch column from the integer to timestamp format. The resulting timestamp will represent the number of the seconds since January 1st, 1970 UTC. Sorry, the hours and the minutes and the seconds are all by 0. The extract function is also used to extract the year from the source epoch timestamp. The resulting value will be an integer representing the year. Okay, so overall this code is useful when you want to retrieve the receipt number, the subnumber, and the source epoch columns from the receipt table and extract the year from the source epoch timestamp column. This extracted data can be useful for grouping or filtering data based on the year of the sales date. Okay, next question. Convert the sales epoch seconds of the receipt details data to date type. Extract only the month. This means month in Japanese, and display 10 items with receipt number and the receipt subnumber. Note that the month should be retrieved with 2 digits. Fail with silver. Well. The character. Extract once. Timestamp sales epoch. So. Yeah, okay. Maybe okay. Boy. Well, I'm gonna explain this. The to underscore timestamp function is used to convert the source epoch column from an integer to a timestamp format. The resulting timestamp will represent number of seconds since January 1st and 1970 and etc. Not etc. Sorry. And extract function. The extract function is used to extract the month from the source epoch timestamp. The resulting value will be an integer representing the month. And the to underscore carry function is used to convert the extracted month to a string with a reading 0 if necessary. This format string specifies that the resulting string should have a fixed weights of 2 characters, with any leading zeros removed. So overall, this code is useful when you want to retrieve the receipt number, receipt subnumber, and the source epoch columns from the receipt table, and extract the months from the source epoch timestamp column. Then format the resulting months as a 2-digit string with a reading 0. This formatted data can be useful for grouping or filtering data based on the month of the sales date. Okay, next question. Convert the sales epoch seconds of the receipt details data to date type. Extract only the day. This means day in Japanese. And display 10 items with receipt number. On the receipt sub number, notes that the day should be extracted with 2-digit field with silver. That's it, come on. Well, I just explained here, right? So, just changing here from month to day. So I will skip this explanation, okay? Next question. Sum the sales amount of the received details data for each customer ID. Binaries the total sales amount to 0 for amounts less than 2,000 yen and for amounts greater than 2,000 yen, and display 10 items with the customer ID and total sales amount. Display 10 items together with the customer ID and total sales amount, however, exclude customer IDs starting with Z as they represent non-members. Well. Where receipt? Where customer ID? Like 10%. This. Wait, this is something again. Then when else it's over as sales log. That's a maybe. Okay, where is it? Huh? I forgot that. Customer ID. Huh? Customer ID. Someone. Where is it? Maybe. Okay. Okay. Well, I'm gonna explain from the beginning. The select statement. No. Where I'm gonna. Well, I will say. From the purpose of this code. The purpose of this code is to calculate the total sales amount for each customer in the receipt table, and also to create a flag indicating if the total sales amount for each customer is greater than 2,000 or not. So the select statement retrieves the customer ID column, the total sales amount for each customer calculated using the sum function. This. And the case expression. The returns 1 if the total sales amount is greater than 2,000 and 0 otherwise. The resulting column that contains the flag is named sales flag, FLG. The where function. The where clause filters out any records where the customer ID is started with the letter Z. This could be used to exclude certain customers from the calculation or flagging. group the results by customer ID so the total sales amount and flag are calculated for each customer. And lastly, the remit clause remains the output of the first 10 results. So overall, this code is useful when you want to calculate the total sales amount for each customer in a receipt table and create flag indicating if the total sales amount is greater than a certain threshold, in this case 2000 or not. This could be useful for identifying high spending customers or for other types of analysis where customer sales amounts needs to be aggregated and analyzed. Okay. Next question, binarize the postcode of the customer data. The one for Tokyo. The first 3 digits are 100 to 209 and 0 for all others. Further, combine it with the receipt details data and count the number of customers with sales results for the entire period for each binary value created. Well, I still need first quiz. Well. I need custom line. Custom. I need this. Maybe I don't need this. When case when solve first when monthly. Integer between 100 and 2000. Case. This can be not good. Maybe okay. Accept. Distinct. Cost Just wait a second. Okay. Showing using customer. Postal CD. Postal supply. Poster plot. Let's see dot customer ID as customer shipment. Maybe okay. Where is it? Can't distinct. Where is it? Distinct count. Here. Okay, right? It's okay. But I'm gonna explain from here. Wait, this SQL code contains a common table expression CTE named cast, which selects the data from the customer table and calculates a postal flag FLG for each customer based on their postal CD. The postal flag FLG flag is calculated using a case expression which checks if the first three characters of the postal CD are between 100 and 209. This is inclusive, and assigns a value of 1. Okay, 1 if true and 0 if false. This work could be used to group customers by postal code ranges, for example. Okay. The second CTE, correct. Second CTE then extracts the distinct customer IDs from the receipt table. The final statement join the cast and rect CTEs on the customer ID column and group the results by the postal FLG column. And this function counts the number of distinct customers for each postal LG value. So overall, this code is useful when you want to group customers by their postal code ranges and count the number of distinct customers for each range based on data stored in the customer and the receipt tables. Okay. Next question. The address of the customer data is one of the Saitama Prefecture, Chiba Prefecture, Tokyo Metropolitan, Kanagawa Prefecture. Create a code value for each prefecture and display it in the cases together with the customer ID and address. The value should be 11 for Saitama Prefecture, 12 for Chiba Prefecture, 13 for Tokyo Metropolitan, and 13 for Kanagawa Prefecture. Well, I'm gonna first introduce what is prefecture. I mean, where is these? Where these prefectures? Okay. Like Chiba Prefecture. Not this. What the? Oh, this is not good. Maps? Where is the maps? News. Well. Prefecture. Okay, now you can see this. This is Tokyo Metropolitan. This is Chiba Prefecture, and this is Saitama Prefecture. Where is Kanagawa? This is Kanagawa Prefecture, okay? They're called Kanto District, or Kanto Region. Okay, that was a kinda study about Japan. Okay. Well, first, from first, personal from it. ID was case when not when sub-string 1 to 3 characters. When Saitama this is just Kanagawa. Come on. Oh, okay. And as what is it? Prefecture. City. Customer ID, substring was when was prefecture. What? Customer listed. Customer ID. Don't need customer ID, maybe? Huh? What the? What is it? Okay, substring address. Why? Maybe we can. No correlation. Okay. I knew it. Hint. Customer ID. Go to customer ID. What is it? Customer ID? Yeah, it can be. Yeah, I knew it. Customer. Customer. Okay. I can get it. This is an example. This is fixed and cut out. So, well, this is called first. Next, I'm gonna make a next code. This is called the second. However, three case substore. So I have units and enter this. It's called to, do, who, can. Sorry guys. So maybe you can type. You guys can type this Japanese or Chinese characters. So maybe I'm really sorry. But this is the second code. I'm gonna introduce this code and the rest customer ID hot dot token. Oh yeah, I need this. Okay. And this is second code using a regular explosion. In a string regular expression. Oh, and I have to. This is not using fix out and a cut out. Okay, I'm going to explain from here. The case explosion in this code checks that the first three characters of address column, okay, and assigns the corresponding prefecture CD value based on the following conditions. I mean the following conditions here. If the first three characters of the address columns are Saitama or Chiba, Tokyo, Kanagawa, the prefecture CD value is set to 11, 12, 13, 14. So, well, I don't need to explain here, okay? And here. So this code is useful when you want to categorize customers by their prefecture based on their address information stored in the customer table. The resulting prefecture CD column can be useful for further analysis or grouping. And this is code example 2 in the version of using regular expression. So I just explain here. So the case expression in this code extracts the prefecture name from the address column using a regular expression pattern. This then assigns a corresponding prefecture CD value based on the following conditions. Well, I just say this, right? So I don't need to explain this anymore, right? So this code is similar to the previous example, but it uses the substring function to extract the prefecture name from the address column instead of the substring function. The regular expression pattern, this matches any string that starts with any character, this, and ends with one of the characters to, do, who, can. Alright, This code is useful when the address information in the customer table is not standardized and includes variations in the format of prefecture names. The resulting prefecture CD column can be used for further analysis of a grouping. And also, I can make a code example 3. This is the usual like version. Customer table version. Okay. The case. Unless like percent. Then does it come on? Otherwise, sorry, like. Okay. It's same result you could get. Why? They are all same. So maybe the case statement checks the address column using the like operator with a string pattern that matches the prefecture of the Japan, followed by any string characters. Okay. This, I mean. If the address column matches any of the patterns, the corresponding prefecture code is assigned. For example, Saitama Prefecture for 11 for Saitama Prefecture, 12 for Chiba Prefecture, 13 for Tokyo Metropolitan, 14 for Kanagawa Prefecture. Okay. This is an alternative way of extracting the prefecture code from the address column, compared to the other two examples shown previously. Okay, next question. Sum the sales amount of the received data for each customer ID and find the quartile point of the total amount. Then create category values for the total sales amount for each customer based on the following criteria, and display the 10 results together with the customer ID and the total sales amount. The category values shall be 1 to 4 in order. Okay. Well. This can be long. by five. Maybe this 5. Limit customer ID and some amount case. This can be long. When the sun amount greater than 25. Then PCT 25. PCT 50. Oops. Then 50, 75, then 3. I don't need this. Come on. What the? Like, where is it? Here. So where is it? Select. Group by customer ID. Underscore. Oh. Okay. Maybe okay. Okay, I'm gonna explain from the beginning. Okay, first, This calculates the total sales amount for each customer by summing the amount column from the receipt table for each customer ID using the sum function, and group by the customer ID. The resulting table is saved as a subquery named sales amount. Okay, and this also calculates the quantile 25th, 50th, and 75th of the sum amount column from the sales amount subquery using the percentile count function, which is a window function. This joins the sales amount subquery with the sales PCT subquery using the close join. Here, okay. Cross-join operation to obtain the quantile values for each rows of the sales amount table. Finally, this calculates a new column PCT group that assigns a percentile group to each customer based on their total sales amount. Like, for example, if the sum amount is less than the 25th, then if the sum amount is greater than or equal to the 25th percentile and less than 50th percentile, then 2, like this. So the final result is limited to the first 10 rows. Okay, this is a little complicated. Okay, next question. Calculate the age in 10 years age increment based on the age of the customer data and display 10 cases together with the customer ID and date of birth. However, our age groups above 60 years should be assumed to be in the 60s. The name of the category representing the age is optional. Well. Dates. Customer ID. Multiple 10 integer. Sixty? Okay. Discussed drunk age. Maybe maybe okay. I'm gonna explain just here because you guys know here the select statement and from a group by statement and limits. So just here. Oh well. Well, the ELA field is calculated by determining the customer's age, which is not explicitly explicitly selected but is used in the calculation, and then taking the raw value between the age, round it down to the nearest decade and 6t. That's it. Well, in summary, this code is selecting information about the customers from the customer table, calculating their age and the era, grouping the results by customer ID and birthday, and filtering out customers whose era is less than 6t. Okay. Next question. Using the extraction result of question 56 and the gender code, create a new category data representing the combinations of the gender, X, age, and display 10 cases. The body of the category representing combination shall be arbitrary. What is this? Oh, FM. Huh? Okay. Well, here, the error is calculating by taking the age of the customer and rounding it down to the nearest decade, with a maximal error of 6t. The gender error string is generated by concatenating the gender CD and error. Okay, so overall, this code creates a summary of customer data that includes age and gender, with an additional error dimension. The resulting table could potentially be used for further analysis and the segmentation of customers based on age and gender. Okay. Next question. Create a dummy variable for the gender code with the customer data and display 10 cases together with the customer ID. Okay. Customer ID. Not ID. Nine, okay. Customer. Okay. Well, this SQL code is selecting customer ID and creating 3 new columns. Gender CD 0, gender CD 1, gender CD 9. These new columns are calculated using the case statement. The case statement is a conditional statement that evaluates a set of conditions and returns the corresponding result. In this case, for each customer, the code checks the value of the gender CD column. If gender CD is equal to 0, the code returns 1, and in the gender CD 0 column and 0 in the other columns. If gender CD is equal to 1, the code returns 1 in the gender CD 1 column and 0 in the other columns. If the gender CD equals 9, the code returns 1 in the gender CD column and 0 in the other columns. Okay. So the resulting output will have the customer ID, gender CD 0, gender CD 1, gender CD 9 columns, where for each customer only one of the new columns will have the value of 1, indicating the gender of the customer. Okay, next question. Sum the sales amount of the received details data for each customer ID. Standardize the total sales amount to mean 0 and standard deviation 1. Display 10 cases with the customer ID and total sales amount. The standard deviation used for standardization may be easier the square root of the variance of the square root of the unbiased variance. However, exclude customer IDs starting with Z as they represent non-members. Okay. Well, was making a some amount that standard deviation ST, what was it? STD, DDV, standard deviation, population, amount, standard deviation. And I need this. Close join. amount. STD def amount as STD amount. That's it. Okay, this is called example first. I'm gonna make it called example 2. That's amount. Let's understand sales amount. Sales amount. First Chani stats amount. What was it about the standard deviation? Customer ID some amounts. Was it sump? Sales amount, the stats amount. The differential here. The same result, right? Just changing here. Sump. But I want to explain this. Okay. This code is performing a data analysis task on a table called receipt first. The table contains transactional data with columns such as customer ID and amount. The code is using a column table expression CTE to create two temporary tables, sales amount and stats amount. The first CTE named sales amount is calculating the total amount spent by each customer who has customer ID that does not start with the letter Z. And it's grouping the transaction data by customer ID, customer ID and calculating the sum of amount for each customer ID. The second CD named stats amount is calculating the average and the standard deviation of the total amount spent by each customer. This is average, this is standard deviation. And the final select statement is selecting columns from the sales amount table. And the join is with the stats amount table using the cross join. It is also calculating the standardized amount spent by each customer by subtracting the average amount and then dividing it by the standard deviation. And the limit 10 at the end limits the output to the first 10 rows. So overall, this code is performing statistical analysis on the transactional data to find the standardized amount spent by each customer who doesn't have to have a customer ID starting with the letter Z. Okay, I just a little just explain here a little. Well, this code is very similar to the previous one. I can say it's almost same, 99%, but there is now one important difference in the stats amount CTE. Instead of using the STDDEV standard deviation population function to calculate the standard deviation, it is using the standard deviation sum function. The standard deviation sum function calculates the sample standard deviation, which is an estimate of the population standard deviation based on the sample data. And in contrast, standard deviation population calculates the extrapolation standard deviation, assuming that the entire population is available for analysis. So the output of this code will be similar to the previous one, but the standard deviation calculation will be based on a sample of the data rather than the entire population. So in general, if the dataset is very large, the difference between the sample and the population standard deviation will be small. However, if the dataset is small, the difference can be significant. Okay, this is the last question for today. Sum the sales amount of the received details data for each customer ID. Normalize the total sales amount to the minimum value of 0 and maximum value of 1 and display 10 items with the customer ID and total sales amount. However, exclude customer IDs starting with Z as they represent non-members. Well, sales amount, this is okay, same amount. Receipt, not like sales amount, select. Amount, sales amount, stat amount, customer ID, some amount, 1.0 multiplied by some amount of the max. I don't need this. And the max amount minus amount. Oops. What? Reset. I have to change here also. Scale. Amount. There is a line 18. Okay. Maybe okay. Well, this code is also analyzing the receipt table, but instead of calculating the standardized amount, it's calculating the scale amount spent by each customer. The code is using two CTE, sales amount and stats amount, which are similar to the previous code. The first CTE calculates the total amount spent by each customer who has customer ID that doesn't start with the letter Z. And the second CTE calculates the maximum and the minimum total amount spent by any customer. The final statement selects the column from the sales amount table and joins it with the stats amount table using a cross join. Okay. It also calculates the scale amount spent by each customer, which is calculated by subtracting the minimum amount spent from the total amount spent, and then dividing it by the range of the total amount spent, which is the difference between the maximum and minimum amount spent. Here 1.0 asterisk before the expression is used convert the result to floating-point number, which is necessary if any of the values used in the expression are floating-point numbers. The limit 10 at the end of the limits at the end limits the output to the first 10 rows. So overall, this code is performing data analysis task to find the scale amount spent by each customer who doesn't have the customer ID starting with the letter Z. The scale amount is a value between 0 and 1 that represents the proportion of the total amount spent by each customer relative to the range of the total amount spent by all customers. Okay, question. Sum the sales amount of the received details data for each customer ID. convert the total sales amount to ordinary logarithm, and display 10 items with customer ID and total sales amount. However, exclude customer ID is written with set as they represent non-members. Well, maybe I can use this code. No. This code? Maybe. Okay. But maybe I don't need this. Well. Customer ID some amount plus receipt customer ID not equals 0 by some amount table or makes 10 or small ID some amount amount plus 0.5 amount 18 yeah don't need this. Okay, well, I'm going to explain from the beginning. This is the SQL query that retrieves the data from database, and the query begins with this. This is called magic comment, which is used in Jupyter Notebook to specify that the following code is SQL code. So the main query selects 3 columns: customer ID, some amount, and this log amount. These columns will be derived from the subquery in parentheses. And the subquery in parentheses first filters out all the records where the customer ID starts with the letter Z. Okay, this is done with the not like Z% condition. The filter records are then grouped by customer ID using the group by clause. The sum function is used to calculate the total amount for each customer ID. As some amount clause renames the calculated column to column to some amount, and the subquery is then aliased as some amount table (TBL). And finally, the outer query selects the customer ID some amount and the logarithm of the sum amount plus 0.5. Okay, this is calculated using the log function and alias as log amount. So the results are limited to 10 rows with the limit clause. Okay, maybe I'm using this code. Okay, next question. Sum the sales amount of the received details data for each customer ID. Convert the total sales amount to the natural logarithm, and display 10 items with the customer ID and total sales amount. However, exclude customer IDs written with set as they represent non-members. Okay. This is okay. Limit. Here. Oh, maybe that's it. Yeah, I just explained here, just changing from, what was it? Log, from log to ln. Well. Well, the outer clause selects the customer ID and natural logarithm with base e of the some amount plus 0.5. This is calculated using the function and areas as log amount. Okay, just explain only that. Next question. Calculate the profit amount of each product from the unit price and the cost of the product data and display 10 results. Okay. Product. CD. Unit price. Cost as that's it. Well. Maybe I don't need to explain this code, right? This is so easy. This is from table, right? I selected product table and selected the column, the product CD and unit price minus unit cost as profit file. Unit profile. Okay. That's not unit profile. It's unit profit. This is the equation that you can get the result of unit profit. Display and 10 items. That's it. Next question. Over the overall average profit margin for each product from the unit price and the cost of the product data. Note, however, that the unit price and cost are missing. Well. Product. Don't need this. Average. And price multiple. Price underneath calculate. 9.0. It's just yeah. That's it. What I want to explain just here because this is so easy. Every G just means average, and this is a SQL function that calculates the average of a given set of values. And this is the formula that calculates the unit profit rate for each product. And this subtracts the unit cost from the unit price and divides the result by the unit price. The manipulation by 1.0 is done to ensure that the division operation returns a floating-point value rather than an integer. Okay. And here, as unit profit rate assigns the calculated value to a column called unit profit rate. Okay, that's it. I'm displaying the end result. Okay. Next question. For product in the product data, find the unit price that gives a profit margin of 30%. However, round down to the nearest yen. Then display 10 results and confirm that the profit margin is approximately around 30%. Note that there is a deficit in unit price and unit cost. Unit price. Unit price. From product. So what? Unit price and the unit cost. Unit cost 0.7. Unit price. Okay. And new profit rate. Price. So what's the difference? Okay. Oh, no, I don't know this. Okay. Well. This code is using a SQL query, a modified version of database table called product. The modification involves calculating a new price for each product based on its unit cost, and then using the new price to calculate a new profit rate. So here, where is the here? With new table as something like sets up a common table expression CTE called new price by TBL. This allows us to define a subquery that can be used in the subsequent query. I'm gonna select here where here is a subquery that selects the data from the product table, calculates a new price based on the unit cost, and assigns it a new column called new price. The trunc function is used to round the calculated new price down to the nearest integer, based on the assumption that the company wants to price their products as a whole number. And here is the main query that selects all columns from the new price TBL CTE and calculates a new profit rate for each product. The new profit rate is calculated by subtracting the unit cost from the new price, dividing the result by the new price, and assign it to a new column called new profit rate, and the limit 10 clause limits the number of rows returned to 10, meaning we only want to see the results for the top 10 results by some criteria, which is not specified in the code snippet. Okay, next question. For each product in the product data, find a new unit price that gives a profit margin of 30%. This time, round to the nearest yen, rounding or rounding to even number is fine. Then display item results and check that the profit margin is 130%. Note, however, there are deficiencies in any price, any cost. Okay. Product velocity 2.7 your price. And invoice DeepL. New price table, new price, unit cost, trunk. That's it. Wait, I'm gonna explain just here. Round. Well, here. This selects the product code, unique price, and unit cost, and calculates the new price for each product by dividing its unit cost by 0.7 and rounding the result. Okay, I don't need to explain here, right? And here. So in summary, this code calculates the new price and new profit rate for each product by using a CTE to temporarily store the necessary data and performing arithmetic operations on the data. Next question. For each product in the product data, find the new unit price that gives us profit margin of 30%. The profit margin of 30%. This time, rounded up the nearest yen, then display item results and check the profit margin is 130%. Note, however, that there is a deficit in the unit price and unit cost. Okay. Product. Just changing here. So, that's it. Finished. This selects the product code, unit price, unit cost, and calculates a new price for each product by dividing its unit cost by 0.7 and rounding up the result to the nearest integer using the cell function. So I didn't explain here, right, everyone, guys? So in summary, this code calculates the new price and the annual profit rate for each product by using the CTE to temporarily store the necessary data and performing arithmetic operations on that data. However, the new price is rounding up to the nearest integer using the cell function instead of being rounded as in the previous code. Next question. For each product in the product data, find the amount including tax as a consumption, tax rate of 10%. Rounding down fractions of the yen and display item results. Notice that the unit price is missing. This is easy. This product. That's it. Don't like it. Product CD. That's always CD. I should use this. Price, don't need any cost. Bye bye. $1.1 as tax price. Okay. Not okay. Tax price 18. 1.1. This is well, I don't explain details, right? Just taking the data from product, display 10 results, and selecting the columns, proximity, price, and well, I'm gonna explain here. Well, first this selects the product code, unique price, and calculates the tax inclusive price for each product by multiplying its unit price by 1.1 and truncating the result to remove any decimal places using the trunc function. So in summary, this code calculates the tax inclusive price for each product by multiplying its unit price by 1.1 and truncating the result to remove any decimal places using the trunc function. Okay, next question. Combine receipt details data and product data and calculate the total sales value of all products for each customer and the total sales value of products whose category major classification code is 07 bottle can food, and find the ratio between the two. Only customer with a sales record for category major category code 07 should be selected, and top results should be displayed. Well, this is a little bit complicated. First making a one. Oh, okay, yeah. Just customer ID. Select customer ID. Some O. Amount to 7. Also this is all. Product as P. This is P product CT. So 7. That's it. Customer ID. Customer ID. Some point amount of subs. That's it. And I don't need this. Okay. P category. Okay. Summer. Okay. But I'm gonna explain from here because this is a little complicated. And here, this defines a common table expression CTE named amount O that is used to temporarily store the data from the select statement and calls in parentheses. Okay. The select customer ID, some amount. I'll explain just here as some from recipe group by customer ID. Well, this selects the number ID, the customer ID, and the sum of the amount spent by each customer from the receipt table, and groups the results by the customer ID. And here, this defines another CTE named amount_07 that is used to temporarily store the data from select statement and calls in parentheses. So here, this selects the customer ID and the sum of the amount spent on products with major category code of those 7 from the receipt and product tables, joins the two tables and the product code, filter the products by the major category code of those 7, and groups the result by the customer ID. Next, this code this selects the customer ID, the sum of the all amount spent by each customer, the sum of amount spent on the category 07 product by each customer, and the sales rate of category 07 product per each customer by dividing the sum of amounts spent on the category 07 product by the sum of all amounts spent by the customer. However, finally, this joins the two CTEs on the customer ID here. On the customer ID and lists the output the first 10 rows. Okay, so in summary, this code calculates the sales rate of categories of 7 products for each customer by first calculating the sum of all amounts spent by each customer, and sum of amounts spent on categories 7 product by each customer, and then dividing the later by the former. It does so by using the CTE to temporarily store the necessary data and performing arithmetic operations and joins on that data. Okay, next question. Calculate the number of days elapsed from the membership application date of the customer data against the sales date of the receipt details data and display 10 items with the customer ID, sales date, and the membership application date. Note that the sales YMD is numeric and application date is a string. Well. Just making. Here, receipt. Distinct. Customer ID. YMD. Receipt. join customer as C customer ID equal C customer ID minus 10. ID customer ID sales YMD application sales YMD as virtual factor and why MDD minus timestamp set application dates MDD sorry as what whoops. Okay. Well, here's code. This defines a common table expression named receipt distinct that is used to temporarily store the data from the select statement and calls in parentheses. So this selects the distinct customer ID and sales year, month, day from the receipt table. I have to explain here. This selects the distinct customer and the ID, customer ID and the sales year, month, days from the receipt table. I already explained here, right? So this this selects the customer ID, sales year, month, day, application date, and the elapsed numbers of days between the customer's application date and the date of distinct sale made by the customer. The calculation of the elapsed day here. The elapsed days involves converting the sales year, month, day, and the application date to timestamps, and then computing the difference between them in days. Finally, this joins the select distinct CTE with the customer table and the table customer ID, and limits the output to the first 10 rows. So in summary, this code calculates the number of days that elapsed between the customer's application date and the date of distinct sale made by the customer by first selecting the distinct customer ID and sales year, month, day from the receipt table, and then join it with the customer table to obtain customer's application date. It then performs calculation involving the conversion of sales year, month, day, and application date to timestamps, and the consumption of difference between them in days. It does so by using a CTE to temporarily store the necessary data and performing arithmetic operations and joins on that data. Okay. Next question. Calculate the number of months elapsed from the membership application date of the customer data against the sales date of the receipt details data, and display an item with the customer ID, sales date, and membership application date. Okay. Receipt distinct is here. Okay. Time, page, table, as table, age table, distinct as oh. Cool. Customer. C dot customer. ID ourselves Y and D. Application date, age to timestamp, just out cells, YMD, by character. Why MDD? Timestamp YMD here. Which timestamp? Why MMDD? Age. Type age table. I forgot to type in it. Table. It's okay. Line 20. Bar character. See application date. Application. Okay. Well, from here. Well, this selects the distinct customer ID and service year, month, day from the receipt table. Maybe you guys know. So, just explain that. Read that. And this defines another CTE named time age table (TBL) that is used to temporarily store the store from the static statement and close in parentheses. So, well, this selects the customer ID, sales year, month, day, application date, and the elapsed time between the customer's application date and the date of distinct sale made by the customer. The calculation of the elapsed time involves converting the sales year, month, day, and the application date timestamps, and then computing the difference between them using the age function. And finally, this joins the distinct CTE with the customer table on the customer ID. Here, this selects the customer ID, sales year, month, day, application date, and the elapsed number of months between the customer's application date and the date of distinct sale made by the customer. The calculation of the elapsed months involves extracting the year, the month components of the elapsed time and converting them to months. And finally, it limits the output the first 10 rows. Okay. So in summary, this code calculates the elapsed number of months between customer's application date and date of distinct sale made by the customer by first selecting the distinct customer ID and the sales year, month, day from the receipt table, and join it with the customer table to obtain customer's application date. It then calculates the elapsed time between the sales month, sales year, month, day, and application date using a CTE and the age function. And converts the results to months. It does so by using the two CTEs to completely store the necessary data and performing arithmetic operations and join the data. Okay, that's here. Next question. Calculates the number of years elapsed from the membership application date of the customer data against the sales date of the receipt details data, and display 10 item is the customer ID, sales date, and membership application date. Oops. Okay. Customer distinct ID sales. Listing sales volume the receipt. This is okay. Receipt. Distinct. That's all. Well, just writing again. But it's almost same code. Then all customer ID. Customer ID and year from time age as voucher. Why MMDD? Timestamp. Well, I made this code previously. MMDD and other upstairs. That's it. Okay. No way. Sorry. Yeah. Okay. This SQL code retrieves the customer ID, sales data, and application data of customers who have made purchases, and calculates the number of elapsed years between the application date and the sales date. So the code starts by creating a common table expression called receipt distinct, which selects distinct combination of customer ID and the sales data from the receipt table. This ensures that each customer is only counted once, even if they made multiple purchases. The main query then selects the customer ID, sales date, and application date from the receipt distinct table and uses the extract function to calculate number of elapsed years between the application date and the sales date. The age function is used to calculate time difference between two dates, and the extract function is used to extract the year component from the resulting interval. Those are here it's okay. So the result is a table that shows the customer ID, sales date, application date, and number of elapsed years per each customer. The limit clause is used to restrict the output to the first 10 rows of the result set. Okay. Okay, next question. Calculate the elapsed time in epoch seconds from the membership application date of the customer data against the sales date of the receipt details data, and display 10 items with customer ID. Sales date. And note that sales YMD is held as a number and application date as a string. Again, note that no time information is held, so each date should represent 0. Well, again, copy and paste. Bye bye. Missing customer ID. Okay. Here. Epoch. From the timestamp. Cast. Also as well can call. The timestamp application date. Sorry, here is yes. Okay. I wanna explain just here. Okay, I don't need to explain this because this is the same with the here. The here. Okay. The main query then selects the customer IDs, sales date, and the main application date from the receipt distinct table, and the user's extract function along with to underscore timestamp function to calculate number of elapsed seconds between the application date and the sales date. The extract function is used to extract number of seconds from the resulting interval. Okay. Okay, that's it. Next question. For the sales date of the receipt details data, calculate number of days elapsed since Monday of the week in question, and display 10 items together with the sales date and the previous Monday. Note that sales YMD holds data in numeric form. Well, again, here's this. Elapsed days. DeepL on receipt. Don't need this. Sure. Why MMDD? Cells YMD. Not timestamp. Right, it's just date. Just YMD. Okay. -1 as a wrap stay. Receipt days. Don't need this. Days as integer as one day. Come on. Okay. Sales YMB. What's the difference? Yeah. Monday. Sales YMD upstairs line 12. Upstairs table. Okay. Well, this SQL call starts by defining a common table expression named upstairs DeepL table, which extracts a day of the week as a number from 0 to 6, where 0 is Sunday, for each sales YMD date in the receipt table. In the main query, here, sales YMD and ops days are selected from the ops days TBLCTE. Then the code calculates a new date by subtracting the ops days from sales YMD. This is done by casting the ops days as an integer and subtracting it from sales YMD. The resulting date is the Monday of the week corresponding to the sales YMD date. The limiting clause at the end of the code limits the output to the first 10 words. Okay, next question. Randomly extract 1% of the data from the customer data and display the first 10 items. Well. Personal ID. That's it. This is the code example first. This is the example why if you want to keep it simple, but however the number of cases values around from 1.0%. Okay, this is code 1. And this is code 2. And this is a little wrong. If you wanna do simple, this is much better. But if you wanna do some more polite, create a count and fix the number of outputs. That's it. So need to make enough ways. Customer. customer. Select asterisks phone number order ordered by random Okay, next. Okay, customers. Okay. Okay, I'm gonna explain from here. This SQL code selects a number subset of 10 customers from the customer table. The random function generates a random value between 0 and 1 for each row in the table. And the where clause filters the rows based on whether the generated value is less than or equal to 0.01. It means 1% chance to be selected. This means that each row has an equal chance of being selected, regardless of any other criteria or other order in the table. The limit code is used to restrict the output to the first 10 rows that meet the condition. Okay, next sample here. Well, the code first making a temporary table called customer temp by selecting null columns from the customer table and adding 2 additional columns using the row number and the count functions here. So the row number function assigns a unique integer to each row in the table based on the result of the order by random clause. This effectively randomizes the order of the rows in the table. And the count function here, with the over clause, counts the total number of rows in the table and created a new column called CNT that contains this count for each row. And the main here select statement then selects a subset of customers from the temporary table by filtering on the row column, which has created by the row number function. Specifically, it selects first 1% of the rows and determined by the CNT column created by the count function. The final clause, the limit 10, just explain 10 results. Okay. So overall, this code is a simple way to select a random sample of customers from a large table for testing or exploratory analysis purposes. The sampling percentage in this case when percent can be adjusted to calculate larger or smaller samples. Next question. Extract 10% of the data, stratified randomly from the customer data based on the percentage of gender code and count the number of cases by gender code. Well. This customer. Okay. Personal ID. customer customer number. That's it. Okay, where is it? Well, line select here. Where is I missed. No shit and T. Oh no, error open. City 0.1 customer number. What the CNT? Huh? You? Maybe here. Personal ID. Not good. So easy. This was user ID. Okay. Well, this code is selecting. Well, this is called example first. I'm gonna make the example 2. Was customer 1 done? Was wait. Row number. Operation. Gender CD. Order by 1 done. That's all in. And 1. Machine count 1, count 9, customer 1 done. CNT by CT. What the? Huh? line 10. Here? Yeah, okay. Okay. Well, I'm gonna explain first here, code 1. This SQL code is selecting random sample customers from code customer and then calculating number of customers in the sample that fall into each gender category. First, this clause creates two template tables, customer random and customer row number, that will be used in subsequent select statement. So first, customer random table. This table selects a random sample of customers from the customer table and assigns each customer a customer all value based on their gender. The CNT column counts the total number of customers in each gender group. And here, customer row number. This table adds a row number, n, to each customer in the customer random table, partitioned by gender. Okay. So, and here, the select statement. This statement counts the number of the customer in each gender group whose row number is less than or equal to 10% of the total number of customers in the gender group. For example, the top 10% of the group customers by row number. The result is a table with two columns, gender CD and customer name, where gender CD is the gender code and customer number is the number of customers in the gender group that fall into the top 10% by row number. So overall, this code is useful for selecting a random sample of customers from larger dataset and then analyzing their gender distribution. Okay. And adding the two additional columns using the row number and count functions. The row number function assigns a unique integer to each row in the table based on the result to the order by random clause. This effectively randomizes the order of the rows in the table. The partition by gender CD clause in the row number function ensures that the random ordering is done separately for each gender group. The count function with the over partition by gender CD clause count the total number of rows in each gender group and creates a new column called CNT that contains this count for each row. Then the main select statement then selects a subset of customers from the temporary table by filtering on the N column, which was created by the row number function. Specifically, it selects the first 10% of rows in each gender group, as determined by the CNT column created by the count function. The where clause filters the rows in the customer window table to only include these with an RL value less than or equal to 10% of the CNT value, their respective gender group. Finally, the main select statement groups the rows by gender CD and returns the count of rows in each group, effectively giving the number of customers in each gender group in the random sample. So overall, this code is a way to randomly select subset of the customers from a large table while ensuring that the sample includes a similar proportion of each gender group as the original table. The sampling percentage, in this case 10%, can be adjusted to create larger or smaller samples. Well. It's same explanation like here and here, right? The just difference is here. I mean the subqueries are different so randomly, and here. Okay. Wait, dog. Well. Okay, next question. Sum the sales amount in the receipt details data by customer unit and extract outliers of summed sales amount. The outliers should be calculated by logarithmizing the total sales amount, calculating the mean and standard deviation, and then deriving from the mean by more than 3 sigma. Either the natural logarithm or the original logarithm is acceptable. Well, I'm gonna explain this for last. Okay. And the sales amount. Customer ID LLN. Month. Where was join standard deviation population STD settlement. And customer ID. Amount. Okay, 23. Hmm. 23. Here? Maybe okay. Well. The code first creates a template table called sales amount by selecting the customer ID and the sum of purchase amount from the receipt table grouped by customer ID. The sum of purchase amount is also transformed into logarithmic scale using the ln function, which adds 0.5 to avoid taking the logarithm of 0. The main select statement here then selects the customer ID sum amount and log sum amount columns from the template table. It also uses the cross join to join another template table called stats amount, which is created by selecting the average and the population standard deviation of the log sum amount column from the sales amount table. The where clause filters the rows in the sales amount table to only include those where the absolute difference between the log sum amount and the average log sum amount divided by the standard deviation of the log sum amount is greater than 3. This is the way to identify customers whose purchase amounts are more than 3 standard deviations from the mean, which is the common threshold for identifying outliers and statistical analysis. So overall, this code is a way to identify the customers who have made significantly large or small purchases relative to the average purchase amount in the dataset by transforming the purchase amount into a logarithmic scale and applying the statistical outlier detection criterion. Okay, next question. Sum the sales amount of the received details data in customer units and extract outliers of the sum sales amount. However, exclude those whose customer ID starts with Z as they represent non-members. Outliers are defined as difference between in the first and third quartiles using IQL and are defined as being below first quartile minus 1.5 multiplied by IQL or above third quartile plus 1.5 multiplied by IQL short-term results. Well. So this is okay. percentile count to point of 5 within group. Multiplied by some amount 25 per. $75. Per minus amount 75 per minus amount 25 per multiple 1.5. Limit 10 and select customer ID amount. Okay, percentile. What the? That's no results. Some amount. Misunderstood it. Or amount 75 per. Percent multiple 1.5. Okay. So this code is using the SQL programming language query database. So, and specifically, it is using the common table expression CTE to create a temporary table called sales amount, which calculates the total amount of sales for each customer in the receipt table. The where clause of the CTE filters out any customers whose ID starts with the letter Z. The group by clause groups the sales by customer ID. The main query here, the performance clause join between the sales amount table and the subquery, the calculation the 25th and 75th percentiles of the sales amount using the percentile count functions. These functions are stored in template table called sales amount. And finally, the where clause of the when query filters out any sales amount that are more than 1.5 times the interquartile range away from the 25th or 75th percentiles. This is the common method for identifying outliers in a dataset. The results are limited to the top 10 rows. So overall, this code is querying a database to identify customers with unusually high or low sales amounts compared to their peers, based on their position in the interquartile range. Okay, next question. For each item of product data, check the number of missing items. Well, product. Measure CD. Measure CD category. Idea. CD. And in the place. Cost. Okay. Well, the query selects 6 columns and gives them aliases that matches the names of the columns in the table. Product CD, category major CD, category medial CD, any price and any cost. So for each column, the case statement checks whether the value is null and returns 1 if it is or 0 otherwise. The sum function then adds up all the ones and zeros to give the total number of null values in each column. The limit 10 calls just displaying 10 results. 10 rows of the table, which is not particularly meaningful in this case since I'm only interested in the summary statistics. So overall, this code is a sample way to check for missing value in the product table and get a quick summary of the number of missing values in each column. Okay. Next, create a new product data, deleting all the records where any items in the product data is missing. Note that the number of the items before and after the deletion should be displayed. And also confirm that the number of items has decreased by the number of items checked in question 79. And this is the last question for today. Well, in this case, zero table. If just product 1 create table product CD product 1 as select this case select product I missed twice is no cost is not null. Okay. And there's the code. Percent SQL. Before relation and first. Right, it's just changed. Right, I'm gonna explain this first. The first line of the code, drop table if exists product underscore one, is a safety measure that checks whether the product underscore one table already exists and drops if it is does, to avoid any conflicts with the new table being created. The second line, create table product underscore one as a parenthesis, specifies that the new table called product underscore one should be created and that its content should be based on the result of the select statement. The select statement selects all columns from the product table, but includes a where clause that filters out any rows where either the unit price or unit cost column is null. So overall, this code creates a new table that contains only the rows from the original product table that have valid data for both the unit price and the unit cost column. This is a common way to clean up the data and prepare it for analysis or modeling, as missing data can cause issues with some analytical techniques. So I just execute it before duration and after duration, you can confirm the difference, right? First question, create a new product data for the missing values of the unit price, a unit cost supplemented by the average value of each. Note that for average values, round of values less than 1 yen, rounding to even numbers is acceptable. After completion, also check that there are no missing values for each item. Okay. Drop table. Product 2. Product 2. Product cross join. From product cost join. Major city. Voice. Cosk. Need to acknowledge as unit. That's product. Okay, it's done. Well, this code is written in SQL language, and it performs the if a table named product underscore 2 already exists in the database, it will be dropped. This is done to ensure that we start with a clean state. A new table named product 2 underscore 2 is created using the create table statement. The data for the new table is derived from the product table using the select statement. So in the select statement, the column product CD, category major CD, category medium CD, and category small CD are selected from the product table, and the two new columns are created in the select statement using the class function. Class function returns the first non-null value in list of expression. In this case, if unit price is null, the average unit price of all the products is used instead. Similarly, if unit cost is null, the average unit cost of all products is used instead. And the form calls in the select statement performs a cross join with a subquery that calculates the average unit price and unit cost of all products in the product table. The round function is used to round the average values to the nearest integer. The result of the select statement is used to populate the product under 2 table using the insert into statement that is implicitly executed by the create table statement. In a summary, the code creates a new table named product underscore 2 that contains the same columns as the product table, but with no values in the unit price, and the unit cost columns replaced by the average unit price and unit cost values respectively, calculated across all products. Okay, next question. Create create new product data for missing values of unit price and unit cost, supplemented by the median value of each. Note that for the median value, round off the figures to nearest yen. Rounding off or rounding to even numbers are acceptable. After completion, also check that there are no missing values for each m. Oh, I missed this, right? Also check the completion values for each then. Okay, I confirm this from product 2 limit 10 product transfer for unit price is not known, then is not known, then as double and as a unit price unit cost what the unexpected indent. What the SQL. Okay. Answer this question. Product CD 3 and 3. Okay, what else in place? Product cross join. Percentile. Simplify. Group. Unit price as unit met. Unit cost met. Have to change this. Okay, also check the code. Okay. Well, the difference between this code is here percentile count 0.5, so I'm gonna explain just here. This only this print. Okay. well, we're in the perspective. Well, the function needs to push. Well, from here, the select statement is executed to query the product three underscore three table. The sum function is used combination with a case expression. I mean those here. Sorry, that was the different explanation. Well, if a table named product underscore 3 already exists in the database, it will be dropped. Okay, this is done to ensure the result with a clean state. And in the select statement, the column product CD, major CD, these columns are selected from the product CD here, just only here, selected from product CD. The two new columns are created in the select statement using the class function. Okay, again explain class function. Returns the false not null value in a list of expressions. In this case, if unit price is null, the median unit price of all products is used instead. Okay, next. Well, round function is used to round the median values to the nearest integer. And the from clause in the select statement performs cross join with a subquery that calculates the median unit price and unit cost of products in the product table. The percentile count function is used to calculate the median values. The within group clause specifies the ordering of the rows so that the function knows which values to use to calculate median. So in summary, this code creates a new table named product underscore C that contains the same columns as the product table, but with new values in the unit price and unit cost column replaced by the median unit price and unit cost values, respectively, calculated across all products. The median values are calculated using the percentile count function with a within group clause that specifies the ordering of the rows. Okay. Next question. Create a new product data for the missing values of unit price and unit cost supplemented by the median value calculated for each product category. Subcategory code notes that the median value should be rounded to the nearest one. Rounding over rounding to even number is acceptable. After completion, also check that there is no deficiency for each item. Oh, okay. 28. Don't need categories. Let's see. Percentile. CD. this. I have to change this. Boy. Select. With a statement. Small city. Cut it. Wine to allow. With category imagine with the CD runs a percentile. Wherever any place in it, custom it. Film product group by small city. Product CD, major city. Seems like it's white code. Oh, okay. And execute again. Okay. this. So I'm going to explain here. Well, this code is written in SQL language and it performs the drop table statement. It's executed to drop the product underscore for table if it's already exists. The create statement is executed to create a product the product underscore table. Common table expression CTE named category median is defined here. The CTE uses a select statement with an order by class to sort the rows in the product table by the unit price and unit cost columns within each category, and then calculates the median values of unit price, any cost for each category, using the percentile count function. The group by clause groups the data by category small CD column. The main select statement retrieves data from the product table and joins it with the category median CTE and the category small CD column. The chorus function is used to replace no values in the unit price and unit cost columns with the median values for their corresponding categories. Now finally, the resulting data is inserted into the products underscore for table using the create table as a syntax. So in summary, this code creates a new table product underscore for by joining the product table with a CTE category median. The median values of unit price and unit cost are calculated for each category in the product table using the percentile count function. The resulting table product underscore contains data from the product table with no value in the unit price and unit cost columns replaced by the median values for the corresponding categories. Okay. Next question. Prepare new data for customers in the customer data by calculating the percentage of 2019 sales value, the sales value for the full period. However, if there are no sales results, treat them as 0. Then extract the calculated percentages that exceed 0 and display the result for 10 cases. Also check that there are no missing data in the data created. Okay. Yep, table if exists. Table sales weight zipped. Don't need this. And customer ID. Accept. This. Accept. Apply. Customer. ID. Go ask. Sorry. When silver then silver as don't need case. Point silver divided by font and cells weight その ID receipt category customer category ID you okay. Well, I'm gonna execute. Right. First I'm gonna explain this. The select statement is executed here. To retrieve data from the receipt and the customer tables. Okay, two subqueries are created to calculate the total sales amount for each customer in the year 2019 and for all years. Or all under 19. Here. And the select statement joins the customer table with the two subqueries using the left join here. Okay, and this ensures that all customers in the customer table are included in the output even if they have no sales data in the receipt table. The chorus function is used here. The chorus function is used to handle cases where a customer has no sales data in the receipt table. It replaces no values with 0. The case statement calculates the sales rate for each customer. It checks if the total sales amount for years is 0, in which case it returns 0. Otherwise, it divides the sales amount for the year 2019 by the total sales amount for all years. The results are inserted into a new table called sales rate. So in summary, the code calculates the sales rate for each customer based on their sales data from the receipt table. The sales rate is the ratio of the sales amount for the year 2019 to the total sales amount all years. The results are saved in a new table called sales rate. Okay. And I have to make again another code. I mean, what was it? So wait. Case. this code is also written in SQL and performs the select statement is executed to retrieve all rows from the sales rate table where the sales rate value is greater than 0. If that was here, it's here, and it's point and results. Okay. This is maybe you learn that this is this flag. For example, when customer ID is null, then one will be returned, or del will be returned, and areas, and this is areas as unit price. Okay. So there are no null values for. It's obvious, right? Seeing this, the code, seeing this, the output. Okay, next question. Create new customer data by linking geocode data to all customers in the closed customer data using post code. However, if a multiple longitude and latitude information associated with a single post code, calculate and use the average values of longitude and latitude also displayed in results to check the criterion creation results. Longitude. Longitude. Latitude. Latitude. Okay. I'm going to explain here. The with clause is used to define the subquery that calculates the average longitude and latitude for each postal code using the geocode table. The select statement joins the customer table with a subquery defined in the with clause using the postal city column. The result of the joint operation is then inserted into the new table called customer underscore 1 using the create table statement. If a table with the same name already exists, it is the first drop using the drop table if exists statement. In summary, this code creates a new table called customer underscore 1 by joining the customer table with the geocode table using the postal city column and appending the average longitude and latitude for each postal code to the customer table. The resulting table has all the columns from the customer table along with two additional columns for the average longitude and latitude. Okay. And this code is the select statement returns all the columns and the rows from the customer underscore table using the asterisk by the code character. Well, in summary, this code retrieves the first 10 rows of the customer underscore 1 table, which contains all columns from the customer table, along with the two additional columns for the average longitude and latitude of each customer's postal code. Okay. Well, next question. For the customer data with latitude and longitude created in question 85 combined with the shop data using the member application shop code as a key. Calculate the distance between the application shop and the customer address using the latitude and longitude information of the application shop and the latitude and longitude of the customer address. And display it together with the customer ID, customer address, and shop address. Display the information together. Maybe don't need this, like. Display it together with the customer ID, customer address, and shop address. The following simple formula should be used as the calculation formula, but rivalry using other highly accurate methods are acceptable. Display 10 results. Okay. When latitude audience is watched and pause audience pause audience longitude longitude Why on on so I need join as see only here. Okay. Maybe okay, but longitude audience well maybe okay. Okay, this SQL code retrieves data from two tables, customer 1 and store, and calculates the distance between each customer's address and corresponding store address. The select statement retrieves the customer ID from the customer underscore 1 table and an address from the customer underscore 1 table renamed customer address and the address from the store table renamed store address. Are calculated value for the distance between the customer and the store using the half sign formula. The cosine and the cosine and cos functions are used to calculate the arc cosine of the sine and cosine of the latitude and longitude of both addresses, respectively. The result is then multiplied by the radius of the earth to obtain distance in kilometers. The join statement combines the rows from the customer underscore 1 and the store table based on the matching application store CD and the store CD columns, respectively. The limit clause limits the number of rows returned to 10. Okay. Next question. In the customer data, the same character is registered more than once, for example, due to applications at different shops. Create the named customer data in which customers with the same name and postcode are regarded as the same customer and located so that there is one record per customer. And calculate number of customer data, the number of named customer data, and the number of duplicates. However, for the same customer, the one with the highest total sales amount shall be retained, and for customers with the same total sales amount or no sales record, the one with the lowest customer ID numbers shall be retained. The table if exists customer year. Let's join receipt. Postal city or SQL. What a boy. hell? Okay. And well, customer. Is it 17 was okay. Well, I'm gonna explain first this. This SQL code creates a new table named customer U by joining data from the table customer and recipient. It first defines a common table expression named sales amount, which computes the total sales amount for each customer by joining the customer table with the recipient table using the left join. Okay. The CTE also uses core resc function here. The function to return 0 for customers who have no sales. Another CTE named a sales ranking is defined by computing the sales ranking for each customer based on the total sales amount within each customer underscore name and the poster underscore CD group. The row number function is used to assign rank to each customer based on the sum amount in descending order. Oh, I need to change this. Maybe. Okay. And finally, the select statement joins the customer table with the sales ranking CTE, filtering only the row where the ranking is 1. This effectively selects only the top ranking customer for each customer name and the poster CD group. The resulting data is then inserted into a new table named customer U. And this SQL queries the number of customers in two different tables and calculates the difference between them. The first part of the code is the subquery here that selects the total count of customers from the customer table and aliases it as a customer CNT. The second part of the code is another subquery that selects the total count of customers from the customer _u table and aliases it as a customer UCNT. So finally, the outer query selects the customer CNT and the customer UCNT from subqueries and calculates the difference between them as diff. This is done by subtracting the customer U_CNT from the customer _CNT. The result is a single row with 3 columns: customer CNT, customer UCNT, and diff. The customer CNT column displays the total number of customers in the customer table, and the customer UCNT displays the total number of customers in the customer U table, and diff column displays the difference between these two counts. Okay. Next question. Based on the data created in question 87, create data with integrated name IDs for the customer data. However, the integrated name ID shall be assigned according to the following specifications. Non-duplicated customers set ID. Duplicate customers set the customer ID of the record extracted in the previous question. The difference between the number of unique customer IDs and number of unique integration name group IDs shall also be checked. Just N. Bye. customer. All customer name. Yeah. Your name. Yeah, that was you. And not equal. As was it ID? If numbers. What the? Okay. Okay, I'm gonna explain here first. This SQL code creates a new table called customer N by joining the existing customer and customer U tables. The join condition matches rows between customer and customer U tables with the same values for the customer name and postal ID columns. For these matching rows, the integration ID column of the resulting table customer N is to set the customer ID from the customer U table. So the customer underscore table includes all the rows from the customer table along with an additional integration underscore ID column that contains the customer ID values from the customer underscore U table. And rows that do not have matching customer underscore name and the postal underscore CD values in the customer underscore U table will have no value in the integration ID column. So next here, Well, this SQL call queries the number of rows in the customer under n table where the customer ID column is not equal to the integration ID column. The customer n table was created in the previous code block by join the customer table with the customer U table using the customer's name and the postal code as the joining criteria. This effectively integrated the two tables by adding the new integration ID column to the customer table, which contains the corresponding customer ID value from the customer U table. So the column query counts number of rows in the customer and table where the customer ID value is not equal to the integration value. This means that there are records in the customer table that do not have a corresponding record in the customer U table, or that have a different customer ID value in the customer U table. This can be used to identify data integration issues and investigate the discrepancies further. Okay, next question. You want to split customers with sales records into training data and test data for building a forecasting model. Split the data randomly in the ratio of 8:2, respectively. Okay. common. Create a table if not in the sales customer. Why it's different? Create a table. Oh. Common. Volume 1. Top table if equals Okay. Customer. Wait, sales. There's a customer. Customer to A. Line 7. Line 7 here. Customer. Where is it? Customer. Customer. Okay, already done. Well. I'm going to explain the detail. This code is using the SQL to create a training and testing dataset for machine learning model based on the customer sales state. So this first sets the seed for the random number generator used in the query. This is done to ensure that sale results are obtained each time the query is run. Okay, next here. This creates a template table called sales customer that contains each customer's customer ID and randomly assign row number. This selects the data from two tables, customer and receipt. Using join, this groups the data by customer ID and filters the result to only include customers who have made a purchase. Some amount is greater than 0. Okay. Next. Here. This creates a table called customer train that contains 80% of the customers in the sales customer table. This selects all columns from the customer table for customers whose row numbers in the sales customer table is less than or equal to 80% of the total number of rows in the sales customer table. Okay, next click. Here. Lastly, this creates a table called customer test that contains the remaining 80% of the customers from the sales customer table. It selects all columns from the customer table for customers whose customer ID is in the sales customer table, but not in the customer train table. This ensures that the test set contains customers that are not in the training set. Okay. And I need also making a complicated data product was and control string and T customer way Lastly, CNT. Okay. Oh, well. Custom tooling. Okay. Well, this code is calculating the percentage of data in the training set and test set based on the tables created in the previous SQL code. So here, this is the main query which tracks the percentage of data in the training set and the test set. This uses training CNT, test CNT, and all CNT variables, which are calculated in the following subqueries. This is the subquery, okay. These subqueries calculate the total number of rows in the sales customer table, the number of rows in the customer train table, and the number of rows in the customer test table. The cross-join operator is used to combine these subqueries into a single table. Since each subquery returns only one row, the result of the cross-join is a single row with 3 columns: all CNT, train CNT, and test CNT. The main query then calculates the percentage of data in the training set and the test set by dividing train CNT and test CNT by all CNT respectively. The asterisk 1.0 expression is used to convert the result to floating point number, which ensures that the division is done with floating point precision. Okay, next question. The receipt details data has data from 1st January 2017 to 31 October 2019. Create 3 sets of data for building time series models, 12 months for training and 6 months for testing, and by aggregating the sales amount on a monthly basis. Okay. this is because this is not SQL oriented, so it's described somehow aggressively. When the number of divisions is large, it is not realistic because SQL becomes wrong. Also be careful when the time series is detailed, such as in seconds, and the data is long term because the data is huge. In such cases, a language that can train models in a root process is desirable, and in such cases, it is desirable to use a language that enables model learning in a root process, like Python. As a preliminary step, total the cells amount by year and month and assign sequential numbers, like this. The next, SQL has its limitation but should be as reusable as possible as the number of datasets created increases. Log functions with clauses are described in such a way that they can be used by changing the log periods. I'm gonna make that. So is 1. Okay. Oh, I forgot. Yeah, I forgot. Come on. Self-file, see. Only 13. So YMD. Okay, successfully won. Well, SQL. This is the data. I'm going to explain this table. This code creates 3 tables with data 1, with data 2, with data 3 by applying a window function to summary table of sales data. Here, this code creates a template table that summarizes the sales data by month function to extract the year and the month from the sales YMD, calculates the total amount of sales, and assigns a row number to each row. The row numbers are used in the subsequent queries to join the data across multiple time periods. Next here. Okay, next is here. Well, this uses the sales data from 6 months as the reference period, while Swiss data 3 uses the sales data from 1 year ago. Okay. This is the same thing with 2, just changing from just change it here. Okay. And this code is a SQL query that selects all columns and rows from the table with data 1. The table with data 1 is created in the previous SQL code block using the create table statement. In the creation of series date 1, the query creates a template table TS amount which calculates the sum of amounts for each month and also assigns a row number based on the month. Using the row number, and the work window function. The query creates a new table series data 1 that contains the sales amount for each month and flag indicating whether the row is the part of the training data or test data. So finally, in this code block, the query selects all the columns and the rows from service data 1, which allows you to view the result of the previous SQL statement. Okay, next question. For each customer in the customer data, undersample the number of customers with sales performance and the number of customers without sales performance so that the ratio is 1 to 1. Where is the seed? Oops. Bye bye. No, bye bye. if I could code with Python, this is so easy. Just making a few codes like for 5 rows. But in SQL, I'm making a lot of codes like this. So, so I like the Python. We're making this kind of code. But in collecting the data, I mean in retrieving the data, extracting the data, the SQL is much better than Python. But for example, like a train test split, I wanna use the train test split function. That's so easy. What is this? Is making a too long the code, not by work. Complete table. Maybe I don't need this. I just wanna delete this for me. So a table. Seriously. Huh? Two. Huh? One? Okay. Table 2. Select. Let's try. Well, I'm confused a little. Please table. Okay, create table. Create table. Where is that? Man. 3 tables, 333. What of course here? Here. Where is it? Syntax select. So where is the select? And now there are two selects here. Where is it? Oh, maybe here. What the? The table sweet? Why? No. Where is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here? んI don't understand. Where is the investment? Select the table, principal. Okay, create temp table. If not, just dump something as display table as. Okay, I knew it. Huh? Risk. Huh? Totally different. Ah. Go up. Risk. Go up. Okay. What the? Well, this is the most difficult things. Regular. Pretty sweet. Select here. So this is a little difficult, not difficult, you know. but I need to find something. So I depend. I need to answer. What was it? 91. Just so where was the I'm not sure. But okay. Yes. Bye bye. The last way. Select. Okay, I'm gonna explain this about this code, too long code. This code is a SQL query that performs downsampling of customer data. Downsampling is the process of randomly removing some data points from datasets that balance the classes or reduce the dataset size. In the query, the first statement sets the random seed value. The next statement creates a template table called downsampling that includes the customer data and the sum of amounts for each customer. The left join clause in the first CTE combines the customer table with the receipt table, calculating the sum of amounts for each customer. In the second CTE, two additional columns are created using the case statement. These columns are flags that indicate whether a customer has made a purchase or not. Then insert CTE, the row under the number window function is used to assign a row number to each customer record based on the is by flag column. So finally, in the last statement in the group of the query, the template table downsampling is selected, but only the rows where the row number is less than or equal to the number of buying customers and the number of non-buying customers. This ensures that the number of rows for each class is balanced in the resulting table. And this code okay. Well, this is a table. This is the table from class, and group by is by flag, and select is by columns and the count 1. Then you can get the is by flag column and the count. Like okay. Maybe okay. Okay, next question. Normalize the to normal form. for gender in customer data. Well. Okay. So Okay, I'm gonna explain this. The SQL code creates the two new tables from the existing table named customer. Here. The first part of the code drops a table named customer std standard deviation if it exists, and then creates a new table named customer std. The new table has the same columns as the customer table, which are customer ID, customer name, gender, city, birthday, age, postal city, post application source city, application date, and status city. The purpose of creating this new table is not clear from the code. I mean, it's clear, but normalize the third form per gender in customer data. So normalize means what I'm talking. It's created to standardize. No, sorry. This code is created to normalize the data, meaning by processing the data. And the second part of the code wraps the table named gender std if it exists, and then creates a new table named gender std. The new table has two columns named gender cd and gender. Gender cd column is a distinct list of all gender codes found in the customer table, while the gender column is the corresponding gender description. This table will be used for mapping the gender codes to their respective gender descriptions. Okay. I'm sorry, I just losing the concentration now. Okay, this code selects the first three rows from the customer std table, which was created in earlier in the code. The customer std table is a copy of the customer table with a subset of columns. So this code is simply displaying the value of those columns for the first three characters in the table. Okay, this is the basic check to confirm that the data has been correctly imported into the new table. Next question. Product data only holds the code values for each category, but not the category names. Combine with category data and denormalize to create new product data that holds category names. Okay. Sorry. The join function. Okay. What the product who? Okay, I'm gonna explain this. This code creates a new table called product pool by joining two tables, product and category. The product table contains information about each product, such as its product code, category codes, unit cost, and unit price and unit cost. The category table contains category codes and category names for each category level. The join clause connects the two tables based on the category small cd column by using the using keyword. The query matches where the values in category small cd are equal in both tables. The new table products pool includes all the columns from the product table plus additional columns for category names, which are obtained by looking up the category codes in the category table. Okay. Yeah, I'm gonna explain this, but don't need to explain too much only. Getting a table from the product cd and displaying 3 results and selecting the old in the columns. That's it. This is just check. Next question. Find out the product data with category names currently in question 93 with the following specifications. Okay. UTF. Oops. 8. Head to. Okay, come on. Come on. Copy product pool to temp. Oh, this is not good. Much. Why? Oh. Wait, code data. Okay, can't. This code exports the content of the product flow table to a CSV file named this. Okay, I mean the name is this. This is the related path. Located in the here directory. The copy them command is a particular SQL command that is used to copy data between files and tables. In this case, the tool keyword is used to specify the file to which the data is copied. And the CSV keyword specifies the file's format as comma separated values, and the header keyword specifies that the first row of the file should contain the column headers. And finally, encoding keyword is used to specify the character encoding of the output as a UTF-8. Okay, next question. Find out the product data with category names created in question 93 with the following specification. I forgot why. The path to be file output destination should be follows: copy command authorization, granted output destination temp / data. So I need this. Okay, by specifying the temp / data, the data is shared with the Jupyter Notes work / data. Okay. Copy product to as product to SJIS. That's it. This code is using the copy command in PostgreSQL. Already explained this, and only the difference is here. This is shift-JIS. Shift-JIS is a character encoding commonly used in Japan, and is one of the several possible character encoding that can be used for CSV files. By exporting the data to a CSV file with shift-JIS encoding, it allows the file to be easily imported into other applications or databases that require this specific encoding. Okay. Next question. Find out the product data with category names created in question 93 with the following specification. And this product pool. UTF-8 and without with CSV no header UTF. That's it. Bye bye. Okay. Just this one is no header, right? Since the header option is not specified, the output file does not include the header row, so the output file will only contain the rows of the data from the product flow table in CSV format. Okay. Next question. Loads the file in the following format created in question 94. Display 3 data items and check that they have been imported correctly. Not copy. Well, first this product pool. Sorry, I'm gonna use this code. This is because this is too long. Okay, done. And getting the result. I don't need to explain this way. Well, explain this. This SQL code drops the table product full if it exists and creates a new table with the same name. The new table has 8 columns. This is okay, 8 columns. And the first 7 columns are type of block character with blowing length, while the last 2 columns are type of integer. By specifying the data types and lengths of the columns, the code is defining the schema of the product full table. This ensures that each column has a specific data type and length, which can improve the importance of queries on this table, as well as prevent errors that may occur if a data of the wrong type or length is inserted. So, copy. SQL product full and okay, it's affected. The code imports data from CSV file located at here into a new table called product full that has already been created in the database. The copy command in PostgreSQL allows you to copy the data from file to a table or vice versa. The from keyword is used to specify the path the CSV sorry, it was not full tool, it was from. What the? What? Copy with the. Oh, maybe because of that. Well, the results are whatever. Encoding 8. Well, this have to be full. Well, zero walls is still. It's not that. Well, that have to be the form, okay. Okay, next question. Will the file in the following form created in question 96 display 3 data items and checks that they are imported correctly? Okay, run product full. Oh, maybe yes. So this is the not good. Okay, so then here will be changed the result. Why not? Well, you can get the result. Why? Okay. I don't need to explain this. Why? Next question. Huh? Okay. Why are the product data with category names created in question 93 with the following specifications? Sorry, I was this is two. The best meter. Well, this have to be here. Okay. Well, I have to explain first here the limit. This limiter specifies, this here, this specifies that the top character will be used as a delimiter. And next is next is the last question. Load the file in the following format created in question 99. Display 3 items of data and checks that they have been imported correctly. Okay, I'm gonna also get the code from here. And get it here. But this is the same way. Same with this. Wait. Same things. Oh, that it's different. Wait, it was a phone. Okay, but the other is same. What the? Huh? What the? I can't well, this is answer code, but I can do it. How about this? Okay. Well, I don't need this way to execute this. Well, this code I'm gonna explain, even if it's I couldn't one, but originally this have to be like this kind of explanation. This code copies data from tsv file located at the I get it, tsv file. So that means from tsv file, and you download the tsv file, right? tsv and the command. Okay, the command. Okay, I could do it. What was the explanation? Sorry. This is a tsv file, and and inserting it into the product flow table in the current database. The copy command specifies the import file as a CSV file with header include the first row of the title of the file, and the delimiter used is a tab character. The encoding parameter specifies that the file is encoded in UTF-8. This command assumes that the product flow table already exists and has the same structure as the data in the output file. Okay. The command will insert the data from the file into the table, creating new rows in the table for each row of the data in the file. And lastly, executing from database product pool and displaying results and selecting the all columns. That's it. Okay. Okay, this is the end of practice 100 knocks. SQL. Okay, thanks for watching, guys.